Hello students, welcome to ACE Online. I'm Aditya, faculty at ACE Engineering Academy. ACE Engineering Academy has conducted pre-GATE exam on 18th January. So here in this video, we are actually providing a detailed solution for all those questions. In the exam, the questions are asked in a jumbled manner, but here in the video solutions, we are trying to explain you subject-wise so that it is going to help in your preparation. I hope this exam and a detailed solution will help you in your preparation. Students, here I am going to solve the questions from engineering mathematics from our pre-GATE paper. So let's look at the first question. So this is about LU decomposition, where they say that F is decomposed as L into U. They gave what is L, and they are asking which of the following is are true. So how does the matrix F look? So it looks like this: F11, F12, F13, F21, F22, F23, F31, F32, F33. So this is F. Now according to the question, F is L into U. What is L? 1, 0, 0. L21, 1, 0. L31, L32, 1. And then we all know U is a upper triangular matrix, which will be like this: U11, U12, U13. Since it is upper triangular, this is 0, and then this is U22, U23. Since this is upper triangular, this is 0, this is also 0, then this is U33. So when you multiply this with this, you have to get the matrix F. He's asking us to check what is the value of F11. If you want this value, then you have to multiply this row with this column. So what is F11, students? This row into this column, 1 into U11. Yes, this is true. He wants you to verify F21. So where is F21? This is F21. How do you get that? Take the second row here, multiply with the first column. So I'm writing it. F21 is, take this row, multiply with this, which is L21 into U11. This row into this column plus 1 into 0 is anyway 0. So it is L21 into U11. Yes, true. Next, they are talking about F22. Take the second row, multiply with the second column. Let's see what is F22. This is the second row, this is the second column. It is L21 U12 plus U22. Okay, so this is this into this, but he says it is just U22. This is false. And then they are talking about F31, that is this element. Take the third row here and the first column here, multiply. So what's the last element they are talking about? F31. This row into this column, this will give us L31 into U11, and then this into this is gone, this into this is gone. L31 into U11, yes, this is a correct relation. And the answers for this problem are A, B, and D. A is a 2 cross 2 matrix such that trace of A is 5 and then the determinant of A is 6. If the characteristic polynomial of A plus I2 whole inverse is x square minus bx plus c, then what is B by C ratio? So they gave they did not give us the eigenvalues. They are saying the trace of A is 5, the det of A is 6. Let's start like this. Lambda 1, lambda 2 be the eigenvalues of A. According to the problem, trace of A is 5, which means sum of the eigenvalues is now 5. The product of the eigenvalues equal to the determinant, and the determinant is given as 6. So we have equation 1, equation 2 as reference. The question is about A plus I2 and then whole inverse. So what would be the eigenvalue of this matrix? Forget about inverse. What is the eigenvalue of A plus I2? It will be like something in the form of lambda plus 1. Since lambda 1 and lambda 2 are eigenvalues of A plus I2. First, let me talk about this. What are the eigenvalues of this? It is lambda 1 plus 1, comma, lambda 2 plus 1. Now, they are talking about A plus I2 and then whole inverse. So, Now this matrix eigenvalues will be like 1 by lambda 1 plus 1, comma 1 by lambda 2 plus 1. The characteristic equation of a plus lambda 2 whole inverse is given, which is x square minus bx plus c. Okay. Now these are the eigenvalues. Let's look at their sum. 1 by lambda 1 plus 1 plus 1 by lambda 2 plus 1. This is sum of the eigenvalues. Sum of the eigenvalues is according to this quadratic equation, you need to focus on what's the coefficient of x. The coefficient of x here is minus b, and then this sum has to be equal to minus of minus b. That's how you deal with the roots and the quadratic equation or any polynomial. So the sum of the roots, so the information lies in the x coefficient, you have to take minus of that. Minus of minus b is b. Keep this as reference. Let's talk about the product of the roots. So 1 by lambda 1 plus 1 into 1 by lambda 2 plus 1. According to the polynomial, so the product of the roots would be directly like c. Now we have this and this. Let us try to simplify this. If you try to simplify this part, there's a cross multiplication. So with that you get lambda 2 plus 1 plus lambda 1 plus 1, and then whole divided by lambda 1 plus 1 into lambda 2 plus 1. This has to be equal to b. Now you can see 1 by this is c. So 1 by this should be c. Try to arrange the numerator in a proper way. Lambda 1 plus lambda 2, 1 plus 1 is 2. Now what I'm trying to say is this is okay, and then you have 1 by this. 1 by this is c. So you have this into c equal to b. We want the b by c ratio. It's easy to get b by c ratio. First of all, what is lambda 1 plus lambda 2? It's 5. 5 and then plus 2 equal to b by c, which is nothing but 7. The answer to this problem is 7. He's just playing with the eigenvalues. They gave a cubic polynomial in the open interval 1 to 6. So what does this have? Let's look at f dash 3x square minus 27. Let's equate this to 0. So x square will be 9, I think, and then x will be plus or minus 3. Ignore minus 3 because minus 3 is outside this interval. So now we'll find f double dash of x. What is f double dash of x? It is 6x. What is f double dash of 3? 18, which is greater than 0. At this stationary point, clearly the second derivative is positive, which indicates that the function is going to have a minimum. So f of x has min at x equal to 3. So the appropriate option would be option B. They gave a function which is max of. How is f of x defined? It is maximum among x and x cube. And then the value of the derivative at f of x at x equal to 0.5. Let us take one interval, because 0.5 lies in this interval, right? 0 to 1. 0.5 lies between 0 and 1. So now in this interval, who is maximum? Is x maximum or x cube maximum? So most of my students might feel x cube is maximum, but in this interval 0 to 1, x is maximum. If you want, you can take any value between 0 and 1, you can check it. For example, take 0.5. What is this value? 0.5. What is this? 0.5 whole cube. Now see which is bigger. You will see 0.5 is bigger than 0.5 whole cube. In this interval, clearly you know what is f of x? It is x. What is f dash? Simply 1. And I need the derivative at 0.5. Since f dash is constant in that interval, which is 1, even at x equal to 0.5, the derivative value is 1. So the answer to this problem is 1. So they gave a function, and then A, B, C, D are the options. You have to choose the appropriate graph. Here, you need to use this logic, you know. So suppose if I say ln e power f of x, then the answer is directly f of x. In the question, there is log and then modulus of e power and then modulus of sine of modulus of x. So that function now resembles like ln e power f of x, where the answer is directly f of x. So that means what is y? Y is simply modulus of sine of mod x. So whatever you are now seeing, that is y, is involved with a modulus function. Whenever you have a modulus function, y cannot be negative. Y cannot be negative. I can see here this portion where y is negative, this is eliminated. I can see here the waveform is below the x-axis where y is taking negative values, eliminated. Now we have two options left over. Let's say at x equal to 0, what's the value of y? Mod 0 is 0, sine 0 is 0, mod 0 is 0. So y value is 0, which matches here. Whereas at 0, it is shown as 1, so this is eliminated. So through elimination, the answer is option C. You can also take some other values like pi by 2 or pi, and then you can verify it. The mode and the modal ordinate of normal distribution respectively are. So for this, you should know what is the probability density function of a normal random variable. What's the probability density function of a normal random variable? It is 1 by root 2 pi sigma square e power minus of x minus mu whole square by 2 sigma square. Let's try to draw the graph of this. So it's a well-known graph. Everyone knows it's a bell-shaped curve which is symmetrical about x equal to mu. So this is your probability density function. First thing is, what is the mode of this? Mode is something where our density function reaches a maximum value. Looking at this graph, at x equal to mu, the density function reaches the maximum value. Hence, the mode for this question is mu. So the mode is mu. Now, after getting the mode, you have to substitute this x value here and then see what is f of x. So at mu, what is f of x value? That is nothing but the modal ordinate. The mode is mu. Substitute x equal to mu into this and extract what is f of mu, which is 1 by root 2 pi sigma square. When I put mu here, mu minus mu is 0, 0 square 0, e power 0 is 1. We are just left with 1 by root 2 pi sigma square. So how much is that? It is, I think, mu, and its modal ordinate is 1 by, because when the sigma square goes out, it becomes sigma. The answer to this problem is option A. So he says there are 3 boxes, box 1, box 2, box 3, containing certain balls. In a random experiment, one of these boxes is selected, where probability of choosing box 1 is 1 by 2, box 2 is 1 by 6, box 3 is 1 by 3. That means they are not uniformly chosen. Box 1 has a higher probability, box 2, and then so on, box 3. A ball is drawn at random from the selected box. Given that the ball drawn is black, what's the probability that it is drawn from box 3? It's a very simple question on conditional probability and then Bayes rule. It's already given that the ball drawn is black. It's already given the ball drawn is black. What's the probability that it was drawn from box 3? So that's the question. If you can find what's the probability of drawing a black object, the problem gets over. So the focus is on what's the probability that you draw a black ball from this. Let's try to write that. So this denominator tries to find what's the probability of drawing a black ball. A black ball can be drawn from box 1 or either from box 2 or from box 3. Look at the way the sentence is created. I can draw a black ball either from box 1 or box 2 or box 3. Choosing box 1, probability is given as 1 by 2 into, if you look at box 1, drawing a black ball, so is 2 by 3. Choosing box 2 is 1 by 6, and from that, drawing a black object is 1 by 3. Choosing box 3 is 1 by 3, and from that, drawing a black ball is 3 divided by 6. This is related to box 1, box 2, box 3. Put this in the numerator to get your complete answer. So this is a very simple model on Bayes rule. So now I'm leaving the simplification to you people. Here they gave a CDF and they're asking what's the median of this distribution. Now when they give you a CDF, you know what's the procedure? We equate. So what we do, we equate the CDF to 0.5. So we have to equate the CDF to 0.5 and then find this x value. So wherever our CDF function becomes 0.5, that corresponding x coordinate will be our median. Now here the CDF value is 0, it can't be 0.5. Here the CDF value is 1, it can't be 0.5. So this is where the CDF can become 0.5. So I have to equate this to 0.5. 1 by 4 x plus 1 whole square is 0.5, which is 1 by 2. This cancels this by 2 times. And then you have x plus 1 whole square equal to 2x plus 1 whole square, or if you remove the square root, it is plus or minus root 2, and x is minus 1 plus or minus root 2. The two values are minus 1 minus root 2 and minus 1 plus root 2. Minus 1 minus root 2, root 2 is 1.414, and when you simplify this, it will be minus 2.414 something, which is outside this value, because your observations are from minus 1 to 1. The median should also be taking a value between that. This is eliminated. Minus 1 plus root 2. You need to use calculator. I'm just finding it roughly. Root 2 value, as far I remember it, 1.414. If you look at the difference, is it 0.41? And then he says round off to 2 decimals. Third decimal is 4. So when I round off, the answer is 0.41. So here x is uniform in the interval 0 to 2, y is x square. They have created a new random variable called y. The probability of y less than 1. So probability of y less than 1. What is y? X square. So what do you mean by x square less than 1? Now when you say x square is less than 1, it means x is from minus 1 to 1. If you can find this probability, the game is over. But if you look at x, it is something which is uniformly distributed from 0 to 2. It takes values only from 0 to 2. So it has, I can write like this, minus 1 less than x less than 0 plus probability of 0 less than x less than 1. X cannot take negative values. The probability of that event is 0. So this event probability is 0. To find this, you need to integrate the probability density function from 0 to 1. 0 to 1. What's the probability density function of x which is uniformly distributed in the interval 0 to 2? The formula is 1 by b minus a, which is 1 by 2 minus 0, so which is 1 by 2. Integration of that will give you 1 by 2, which is 0.5. The probability of occurrence of this event y less than 1 is now 0.5. They gave m and their eigenvalues are 1, 2 and 3. They have created a new matrix P. Which of the following statements are correct? The determinant of m is 6. The determinant of a square matrix is equal to the product of eigenvalues. 1 into 2 into 3 is 6. Yes, this is true. A simple result. The eigenvalues of P are 6, 6 and 6. So this is R. The eigenvalues of matrix P are 6, 6, 6. I want to find the eigenvalues of P. For that, I'll substitute the eigenvalues of m. So the eigenvalues of P are, it's 1 cube minus 6 into 1 square plus 11 into 1, which is 6. The first eigenvalue is 6. I have to put 2 here. 2 cube minus 6 into 2 square plus 11 into 2. How much is this? 8 minus 24 plus 22. This is minus 2 plus 8 is 6. Second eigenvalue is also 6. And then I have to put the third eigenvalue here. 3 cube is 27. 3 square 9, and then 6 into 9, 54 plus 33. So how much is this? 27 minus 54 minus 27. Minus 27 plus 33 is 6. Yes. The eigenvalues of the matrix P are 6, 6, 6. This is correct. The trace of M inverse is 11 by 8. The trace is equal to the sum of the eigenvalues. Trace of M inverse, if you want, you have to add the eigenvalues of M inverse. The eigenvalues of M are given. M inverse eigenvalues are reciprocal, so it is 1 by 1 plus 1 by 2 plus 1 by 3. So its denominator is 6. So it is 6 plus 3 plus 2, which is 11 by 6. Yes, trace of M inverse is 11 by 6. The matrix M is not diagonalizable. M has got distinct eigenvalues. So whenever you have a distinct eigenvalues, yes, M is diagonalizable, but he says it is not diagonalizable. So distinct eigenvalues will guarantee that the matrix is diagonalizable. This is false because M is actually diagonalizable. So they say that V is R power 4. W is the subspace of V spanned by the vectors V1, V2, V3. Let P be a projection matrix that projects any vector in V into the subspace W. Which of the following statements is or true? And then various options are given. If you observe V1, V2, V3, V1, V2, V3, is there any linear relationship between V1, V2, V3? I can see that V3 is V1 plus V2. Check it. 1 plus 2, 3, 2 plus 5, 7, 0 plus minus 1, 3 plus 5, 8. So whatever vectors are given, they are actually linearly dependent. So this is not an independent set, it's a dependent set. Now I can clearly see that this element is 0 and here this element is non-zero. There is no way I can express V2 in terms of V1. So I feel V1, V2 to be independent. So V1, V2, V3, okay, they are part of W. I need the dimension of W, students. I need dimension of W. Some students might feel, since 3 vectors are given, this W subspace spanned by the vectors, that's okay. But how many of them are independent in that? V1, V2 are only the independent one. Hence, the dimension of W is 2. It's not 3. So this is gone. Majority of the students might feel A is right. The rank of the projection matrix is P. So is P the projection matrix for the subspace W? Yes. Then we have a property that rank of the projection matrix is equal to the dimension of the corresponding subspace. The corresponding subspace is W and its dimension is 2. So rank of the projection matrix has to be 2. This is correct. So the projection matrix is idempotent such that P square is P. It's a nice important property of a projection matrix that it is idempotent. It is symmetric. Its eigenvalues are either 0, 1. There are many such properties. Idempotent is one such property the projection matrix is going to obey. The nullity of I minus P is 2, where I is the 4 cross 4 identity matrix. So they are asking you the nullity of I minus P. So very, very interesting. I can say the nullity of any matrix is, I can see that its order is 4, so it is 4 minus rank of I minus P. So you have to find rank of I minus P. And I also know that rank of P plus rank of I minus P has to be 4, because you can see that the subspace W and its orthogonal subspace, they are like subsets of R power 4. So this rank has to be, sum of these ranks has to be equal to 4. So this is from rank plus nullity theorem concept. Now this is given as 2. This is given as 2. Then what is rank of I minus P? So rank of I minus P is 4 minus 2, because we know rank of P. So rank of I minus P is also 2, students. Substitute that. It is 4 minus 2, which is 2. So this is a true statement. So the answers are B, C, D. And also, students, please remember a fact, nullity of what? Here we are talking about nullity of I minus P. So there's an interesting property which says nullity of I minus P is always rank of P. Okay, so nullity, I'm not saying rank of I minus P is rank of P. No, I'm saying rank of nullity of I minus P is rank of P. So these are the 1 mark questions and their solutions, and next we will be solving 2 mark questions. Let x and y be independent random variables where x follows a Poisson distribution with mean lambda 1 and y follows a Poisson distribution. Both are actually Poisson random variables, they are independent, and the parameters or the mean values are lambda 1 and lambda 2. They created a new random variable w, which is x plus y. Which of the following statements are correct? And various options are given. The conditional distribution of x given w equal to n is a binomial with parameters n and p equal to lambda 1 divided by lambda 1 plus lambda 2. The mean of w is lambda 1 plus lambda 2. The variance of w is lambda 1 square plus lambda 2 square. The conditional mean of x for a given w equal to n is n into lambda 1 by lambda 1 plus lambda 2. So here are the various options. The first thing I want to decode is what is w. Students, try to analyze what is w. W is given as x plus y. X, y are independent, they are Poisson random variables. Let's try to find what is the expected value of w. It is expected value of x plus expected value of y. The mean of x is lambda 1, the mean of y is lambda 2. Hence, the mean of w is lambda 1 plus lambda 2. The first correct statement I have identified is yes, the mean of w is lambda 1 plus lambda 2. For a Poisson random variable, students, do you know what is its variance? Its variance is same as the mean, hence the mean of, not the mean, the variance of x is lambda 1. The variance of y is also equal to its mean, which is lambda 2. It is clearly given x and y are independent. In the case of independent events, I am now interested in what is variance of w, which is same as variance of x plus y. When you are having x plus y to be independent, the variance of x plus y is simply variance of x plus variance of y. Variance of x is lambda 1, variance of y is lambda 2, the variance of w is lambda 1 plus lambda 2, and he says it is lambda 1 square plus lambda 2 square, which is wrong. And then we are left with a and d. So if you can analyze a and d, we are done with this problem. Let's go to the next page. So what does he say? The conditional distribution of x given w equal to n is a binomial with parameters n and p as lambda 1 by lambda 1 plus lambda 2. If you can answer this, you will get an idea about d as well. He's talking about the conditional distribution. Okay, so conditional distribution. Let me represent like this. The conditional PMF of x given w equal to n. So this is what is asked. So we need to find the probability of x equal to, let's say, some k given w equal to n. So this is how the conditional PMF is defined. Now this is clearly a conditional probability. You can also write this as the probability of x equal to k intersection w equal to n divided by the probability of w equal to n. So the next thing is to simplify this properly. So what does he say? Here, if you look at the numerator, x value is fixed as k and w value is given as n. So x equal to k intersection w according to the given question is x plus y, and this has to be n divided by the probability of w equal to n. So when you are adding two Poisson random variables, two independent Poisson random variables, the sum is also a Poisson random variable. So what is w? W is also Poisson with the parameter or the mean or the parameter equal to lambda 1 plus lambda 2. So w is also Poisson. So we know a fact that sum of two independent Poisson random variables is again a Poisson random variable with the mean as lambda, with the mean as, where is that? Where is the mean? Where did I find the mean of W? Yeah, mean of W as lambda 1 plus lambda 2. So I know how to find the probability of this event. So let's try to write this in a proper way. Here x is fixed as k. When x is fixed as k, so here x is k and then intersection with. Now when you are looking at the intersection, again x is k, so you can use that k here. It is k plus y equal to n, or simply the value of y is n minus k, and then divided by the probability of w equal to n. So here x and y can be any values, but the sum has to be n. But here we are very particular, x should be k, y should be n minus k. So what next? Clearly x and y are independent. You can write this as the probability of x equal to k into the probability of y equal to n minus k, and then whole divided by the probability of w equal to n. This is Poisson, this is Poisson, this is also Poisson. You know the PMF of all the Poisson random variables, substitute to get the answer. Let's go to the next page. So here the probability of x equal to k. So what is that? It is e power minus lambda or lambda 1 and then lambda 1 power k by k factorial into probability of y equal to n minus k. So this is also Poisson whose parameter is lambda 2. So it's e power minus lambda 2 power n minus k divided by n minus k factorial. And then w is also Poisson and it is equal to n. So whose parameter, what's the parameter of w, or what's the mean of w? Lambda 1 plus lambda 2. So this will be like e power minus of lambda 1 plus lambda 2 and then lambda 1 plus lambda 2 whole power n by n factorial. E power minus lambda, e power minus lambda 1, e power minus lambda 2, and then this cancels. So try to arrange the remaining terms in a proper way. This n factorial goes to the numerator. This will be like n factorial by k factorial into n minus k factorial, and then you have to arrange the terms in a proper way. So how shall I arrange them? Maybe I'll arrange it like this. Check this. Lambda 1 by lambda 1 plus lambda 2 whole power k. Okay, lambda 1 power k is anyway available. And then here I have lambda 1 plus lambda 2 whole power n. Whole power n can be written as n minus k plus k, and then I separated them. And then what is left is lambda 2 lambda 2 power n minus k, and here lambda 1 plus lambda 2 whole power n minus k. You can actually club them. So this will be like, is this nck? Yes. And then this is like lambda 1 by lambda 1 plus lambda 2 whole power k. And then this, the first step you can write as lambda 2 by lambda 1 plus lambda 2 whole power n minus k. You know, this resembles like nck p power k 1 minus p whole power n minus k. If this is p, students, then this expression is 1 minus p. If you have a doubt, you can check it like this. Go to the next page. If I say p is lambda 1 by lambda 1 plus lambda 2, then what will be 1 minus p? 1 minus lambda 1 by lambda 1 plus lambda 2, which is lambda 1 plus lambda 2 minus lambda 1 by this denominator. And then after cancellation, it is lambda 2 by lambda 1 plus lambda 2. So what I'm trying to say is, finally, what are we trying to find? We are trying to find the conditional PMF. So the conditional PMF of x, the conditional PMF of x given w equal to n. How does this resemble? It resembles like nck p power k 1 minus p whole power n minus k, where n is n and p is lambda 1 by lambda 1 plus lambda 2. So this is clearly the conditional PMF is now behaving like a binomial random variable, students. What random variable? Binomial random variable with parameters n comma p, which is equal to lambda 1 by lambda 1 plus lambda 2. So that is what they are saying in option A, which is true. And then in option D, they are asking what is its mean. Now students, what's the mean of a binomial random variable? The mean of a binomial random variable is np, that is n into lambda 1 by lambda 1 plus lambda 2. Sir, how did you get that easily? Now once you say that this is the binomial random variable, then its mean is np. N into p. P we have just now found, that is lambda 1 by lambda 1 plus lambda 2. So that means this is also the correct answer. The answers for this question A, B, D. Here they gave a joint PDF and they are asking what's the value of C, whether they are independent or not, expectation of x is equal to expectation of y, and the covariance is positive. You have to verify all this. So first thing is we have to find the value of C. So let us use this property. If you perform the double integration, so the double integration of that PDF should give us 1. X limits are 0 to 1, y limits are 0 to 1, C outside it is x plus y dy dx. So this double integration value should be 1. With that you will get the value of C. So C into x from 0 to 1, the integration of this is xy plus y square by 2. There is one more integration which is left with respect to x. This has to be 1. So if you simplify this, when I put the limits of y, I get x plus 1 by 2, where x is from 0 to 1, you have c, and then this integral value has to be now equal to 1. C into x integration is x square by 2. If I substitute the limits, it will be 1 by 2. 1 by 2 x, 1 by 2 integration is 1 by 2x. When I substitute the limits, it is 1 by 2. The lower limit will be 0. Sorry, lower limit will be 0, and then this has to be equal to 1. 1 by 2 plus 1 by 2 is 1, meaning by the value of C is 1. Yes, C is 1. To decide whether they are independent or not, I need the marginals. So let's find the marginals. How do you find the marginals? Fx. To find this, the integration should be done from y equal to 0 to 1. So our joint PDF, which is x plus y dy. So this is how it is done. So with respect to y, so x is constant, this is xy plus y square by 2. The limits are 0 to 1. So this gives you the answer as x plus 1 by 2. So what's the marginal of x? The marginal of x is x plus 1 by 2, where x is in the interval 0 to 1, and outside this it is 0. Now I can also directly tell what is marginal of y, because our joint PDF is simply x plus y, x to the power 1 plus y to the power 1, and the limits are also identical. You can easily tell what's the marginal of y. Marginal of y is y plus 1 by 2 in this limits, and outside this is 0. Now I have to decide whether they are independent or not. So for that, if I multiply fx with fy, I should get f of x comma y, that is the joint PDF. So x plus 1 by 2 into y plus 1 by 2, this is nowhere equal to x plus y, students. So meaning by we don't have this condition f of x comma y equal to fx of x into fy of y. Such condition is not satisfied in this question. They are not independent. So when they are not independent, this is false. And then we need to find expectation of x. Is it equal to expectation of y? Since they have the same marginals, when you try to find their expectation, yes, their expectation would be true. So without any hesitation, I can say this is true. And then they are asking you covariance of x comma y. To find the covariance, again you need expectation of x and expectation of y. So it's better we find expectation of x. Expectation of x is integral x from 0 to 1. It is x into the marginal of x. The marginal of x is x plus 1 by 2, and you have to perform the integration. So the first term is x square, whose integration is x cube by 3, and then this is x square by 4. The limits are 0 to 1. So it is 1 by 3 plus 1 by 4 is it 7 by 12. So expectation of x is 7 by 12. Expectation of y is also 7 by 12. Now we need the covariance. To find the covariance, we also need expectation of xy, which is x from 0 to 1, y from 0 to 1. It is xy into the joint PDF, which is x plus y, and then dy dx. So once you get this, then substitute in the covariance, you'll get the answer. The first term is x square y plus x y square, and then you have to perform the integration. So I'll write it directly. First integration is with respect to y. It is x square y square by 2 plus x y cube by 3, y from 0 to 1. If I put those limits, it will be like x square by 2 plus x by 3. Now I have to perform the integration with respect to x, which will be like x cube by 6 plus x square by 6. Limits are 0 to 1. So 1 by 6 plus 1 by 6 is 2 by 6, which is 1 by 3. So now we know expectation of xy. Now covariance of x comma y. It is expectation of xy minus expectation of x into expectation of y. This is 1 by 3 minus 7 by 12 into 7 by 12. So you might need the virtual calculator here. So let's see its value. 1 divided by 3 minus 7 by 12 and then square. So when I see this, I'm getting a negative value minus 0.0069, something like that. So this is definitely less than 0. But he says the covariance is positive. So this is wrong. The answers to this problem are A, C. So A, C are the right answers for this question. Let's look at this question. X is Poisson with parameter value as lambda. Y is binomial with parameters n comma p. Which of the following are correct? So for y, the mean is equal to the variance. So now what do you know about binomial? So the expected value of a binomial random variable is np. What's the variance of the binomial random variable? It is np into 1 minus p. And option A says the mean is equal to variance. Are these two equal? No, it need not be equal. So this is a false statement. Y can be approximated by x, that is a binomial random variable can be approximated as Poisson when n is large and p is small, such that lambda or np equal to lambda. Yes, so we have this concept where a binomial random variable can be approximated using a Poisson random variable, where we set the lambda value as np. This is true. The sum of two independent Poisson variables is also Poisson. Yes, the sum of two independent Poisson random variables is again a Poisson random variable. The same thing applies for binomial as well. So the sum of two independent binomial random variables whose parameters are n1 comma p and n2 comma p, where the probability of success in both the cases is same, then the resultant sum is also binomial with parameters n1 plus n2 comma p. So it's a theoretical question. This is right. So option C is right, option D is right. The answers to this problem B, C, D. Let's go to the next problem. Let x be a random variable having a Poisson distribution with mean lambda, which is greater than 0. The expectation of 1 by x plus 1 given x greater than 0. So try to recollect what is the probability mass function of a Poisson random variable. So the probability of this event is e power minus lambda, lambda power k by k factorial, where k values are from 0, 1, 2 and so on. Now he is asking us for x greater than 0, what is the expected value of 1 by x plus 1? Try to recollect what is expected value of g of x. Expected value of g of x is summation over all the values of x. It is g of x into the probability mass function of x. So this is expected value of a function of a random variable. Here in the place of g of x you have 1 by x plus 1, and also it's a conditional mean. So what values of x you will take is clearly the values of x where x is greater than 0. So now the required answer, that is the conditional mean of 1 by x plus 1 given x greater than 0. So it is given by summation, where x is clearly says x greater than 0, so x should be from 1 to infinity. It is 1 by x plus 1, and the probability mass function is e power minus lambda, lambda power x by x factorial. Now you substitute various values of x and then expand the summation, see what would be the final answer. So this needs some skill here. So substitute these values in a proper way. Firstly, I can take e power minus lambda common. When I put x as 1, it is 1 by 2 into lambda power 1 by 1 factorial. Put x as 2, it is 1 by 2 plus 1 is 3, 3 into 2 factorial into lambda square, plus it would be lambda cube by 4 into 3 factorial plus so on. So you can see lambda power 1 is there, but in the denominator you have 2 factorial. You have lambda square, but in the denominator you have 3 factorial. You have lambda cube, but in the denominator you have 4 factorial. I can do that adjustment, like I'll multiply and divide with lambda. So it's e power minus lambda by lambda into, this will be like lambda square by 2 factorial plus lambda cube by 3 factorial plus lambda power 4 by 4 factorial and so on. Now you have a simplified expression for this. So if you look at e power lambda expansion, it is 1 plus lambda by 1 factorial plus lambda square by 2 factorial, lambda cube by 3 factorial and so on. Suppose if I want only this value, lambda square by 2 factorial plus lambda cube by 3 factorial plus lambda power 4 by 4 factorial and so on, then these two terms go to the other side, so it becomes e power lambda minus 1 minus lambda. You can now substitute this. So let's see what happens to our required answer. So when I substitute this, let's see, it will be e power minus lambda by lambda out, and then this inside summation is now equal to, it is e power lambda minus 1 minus lambda. So now, is there any answer? Maybe we need to multiply this e power minus lambda inside. When I multiply this into this will be like 1, and then minus e power minus lambda e power minus lambda whole divided by lambda. So this is the required expected value. Do you have this kind of option? Does option C match? Yeah, option C matches with our answer. You can see everything is here in option C. So that's how you take the conditional mean here. So what are they saying here? X is a normal random variable with 0 mean and variance 1, meaning by x is a standard normal random variable, y is x square, and z is sin pi x. Which of the following statements are true? The first one is the covariance of x comma y is 0. First of all, what is covariance of x comma y? By definition, it is expected value of xy minus, it is expected value of x into expected value of y. Since x is standard normal, the mean is 0, so this goes away, so there is no need to find the expectation of y. So what is the covariance now? The covariance of x comma y is directly expectation of xy, because like I said, this is 0. Now how do you find expectation of xy? Expectation of xy, can I write like this? Expectation. What is y given in the problem? Y is x square. So now this is expected value of x cube. Now that odd power will help us in solving the problem. How do you find expected value of x cube? It is integration minus infinity to infinity x cube into the probability density function of a zero mean and unit variance normal random variable, which is 1 by root 2 pi e power minus x square by 2 dx. This is odd, this is even. Odd into even will produce an odd function, and integrating an odd function from minus infinity to infinity will give you the answer as 0. So what's the logic? Integrating an odd function within minus infinity to infinity limits will give you 0. So if expectation of xy is 0, this is 0, then the covariance is also 0. Yes, option A is true. Now I have to verify the other options, covariance of y comma z. So let's solve it here. Covariance of y comma z. It is expected value of yz minus expected value of y into expected value of z. So what is the expression for z? It is sine pi x. How do you find expected value of this? It is integration minus infinity to infinity sine pi x into the probability density function of x, which is 1 by root 2 pi e power minus x square by 2 dx. This is odd, this is even. Again the same logic, odd into even produces an odd function. Integrating within that limits will give you the answer as 0. The moment expectation of z turns out to be 0, there is no need to find expectation of y. So this is gone now. We are supposed to find expectation of yz. So what will be expected value of yz? What is y in the given problem? X square into sine pi x. Come on, it is integration minus infinity to infinity. It is x square sine pi x into the probability density function of x. X square is even, sine pi x is odd, even into odd is odd, and then this odd into even is again odd. Again, integrating an odd function will give you 0. So expected value of yz is 0. This is 0, this is 0, which means covariance of y comma z is 0. So this is also true. Now they are asking what is covariance of x comma z. What is covariance of x comma z? Okay. So most of you might be feeling like in the previous way, this might also be 0. We need to examine it. Covariance of x comma z. It is expectation of xz minus expectation of x into expectation of z. This is 0, this is 0, and then you have to find expectation of xz. So what is expectation of xz? It is integration minus infinity to infinity x, keep x like x, z is sine pi x into 1 by root 2 pi e power minus x square by 2 dx. This is odd, this is also odd. Odd into odd will produce an even function. This is even function. This is also even function. Even into even is again an even function. So we are supposed to do the integration. And one more logic is that e power minus x square by 2. So if you check the graph, for smaller values, the values which are close to 0, you can see the density function is taking larger values, mean positive, higher values. This integral need not be 0 actually. First of all, it is not an odd function. The entire thing is an even function, and when you are looking at the values close to 0, it actually takes the higher values. So this integral need not be 0. this is need not be 0 means this need not be 0. So the covariance of x comma z need not be 0. So you can't say that this is 0, this is false. A, B are true so far, and then he says x and z are independent. X and z are independent. Arey, what is z? Sine pi x. Now if you say they are independent, if I give you the value of x, see here, this expression itself z equal to sine pi x tells x and z are related, actually they are dependent on each other. You give me x, I'll tell you what is z. You give me x value, for example x is 1, then sine pi is 0, so z is 0. So you can't say that they are independent, they are actually dependent and there is a clear relation between them. So this is clearly a false statement. X and z are independent is false. The answer to this problem is, it is A and B. The answers are A and B. So let's look at this question. Let z1, z2 up to z10 be independent and identically distributed standard normal random variables where zi is like standard normal, he says. Define two random variables y, which is summation I from 1 to 5 zi square, and w is I from 6 to 10 zi minus 2 whole square. Which of the following statements are correct? Now when z1, z2 are standard normal, when you square them and add them, then that leads to chi-square distribution. So you can see that here z1 square plus z2 square up to z5 square is there. It is clearly a chi-square random variable with 5 degrees of freedom. So when I look at this expression, summation I from 1 to 5 zi square, this is chi-square n, where n is 5, it's a chi-square n random variable. So he also says the random variable y follows chi-square distribution with 5 degrees of freedom. Yes, this is true. The expected value of y plus w is 30. We need to examine that. The variance of y is 10. The variance of a chi-square random variable is twice the degrees of freedom. So here 5 random variables are in the discussion. So it's 2 into 5, which is 10. The variance of chi-square random variable is 2n. Yes, this is correct. Now in option B says expected value is 30. In option D says expected value is 20. I can first say like this: expected value of y plus w is expected value of y plus expected value of w. The expected value of a chi-square random variable is directly equal to its degrees of freedom. So 5 degrees of freedom here, plus I need to examine what is expected value of w. We'll go to the next page. Imagine what, write what is w. W is summation I from 6 to 10. It is zi minus 2 whole square. Let's expand this. Here 5 random variables are in the discussion because I is from 6 to 10. So 6, 7, 8, 9, 10, 5 random variables are in the discussion. So I from 6 to 10, it is zi square plus 2 square is 4 minus 4 zi. Let's take expectation. Expected value of w will be summation I from, so you will have the expectation on this, and then you will have expectation on this, summation I from 6 to 10, 4, and then 4 can be brought out, so minus 4, it is expected value of summation I from 6 to 10 zi. Now this is again resembling like sum of squares of standard normal random variable, which is nothing but a chi-square random variable here. So this summation, if you see, it's a chi-square random variable with again 5 degrees of freedom. So expected value of that will be 5. Here 4 is added 5 times, so 4 into 5 is 20. When this expectation goes inside, it is expected value of zi like Zi is a standard normal, expectation of Zi is 0, and this expectation, like if you take it, is going to be 0. And then how much is this? This is 25. This is expected value of W. So I need expected value of W, which is 25, and altogether it is 30. So this is the right answer and this is wrong. So the answers for this question are A, B, C. Let x1, x2 up to xn be independent and identically distributed random variables following a uniform distribution, that is from 0 to 2. Let Sn is a summation of I from 1 to n xi. According to the central limit theorem, which of the following statements is are correct for large n values? The variance of the limiting distribution of Sn minus n divided by root n is 1 by 3. The probability of Sn less than or equal to n plus root of n by 3 is 0.8413. Probability of Sn greater than n is 0.5. The distribution of Sn converges to normal distribution only if n tends to infinity and xi are normally distributed. Now from central limit theorem, it's very clear that when you are looking at the sum of IID random variables, xi need not be normal random variable. It can have any distribution. So without any analysis, option D is definitely a false option. Option D is gone. So there is no need to work on this. This is gone. Now the question is about AB. See, it's a MSQ. What is Sn? Summation I from 1 to n xi. Expected value of Sn. It is sum of the IID random variables. So it is n into expectation of xi. N into xi is a uniform random variable whose mean would be b plus a by 2. So 2 plus 0 by 2 is 1. So the mean of xi is 1 and the mean of Sn is now n. What is variance of Sn? What is variance of summation of xi? Since they are IID, there is no covariance involved. It is n into variance of xi. N into, try to recollect what's a variance of a uniform random variable. B minus a whole square by 12. So 2 minus 0 whole square is 4. 4 by 12. So 4 by 12 is 1 by 3. And then the variance of Sn is n by 3. And then the standard deviation of Sn will be square root of this, just root of n by 3. So he's asking the variance of now new quantity. It is not variance of Sn. They are asking you variance of Sn minus n by root n. Okay, let's go to the next page. So try to recollect what is variance of Ax minus b. It is a square into variance of x. Now what they asked is what is variance of Sn minus n by root n. You can split this like variance of 1 by root n into Sn minus n by root n is root n. This now clearly resembles like variance of Ax minus b. What is variance of Ax minus b? It is a square. So the square root and n cancels. It is 1 by n into variance of Sn. Variance of Sn. What is variance of Sn, students? N by 3. So it is 1 by n into n by 3 gives you the answer as 1 by 3. What next? So yes, option A is correct. And then they are asking you the probability of the remaining events. Option C is very simple, you know. Since n is large, sum of IID random variables have a normal distribution according to central limit theorem. So now what we know is Sn is clearly, because it is dealing with sum of IID random variables, as n is large, Sn has a normal random variable nature whose mean, what's the mean? Mean of Sn, students? N. What's the variance of Sn, students? Variance. So did we write variance of Sn? Yes, n by 3. For a normal random variable, if you are asking what's the probability that it is greater than mean, then what we usually do is we draw a bell-shaped curve which is symmetrical about n, and you are asking a question, what's the probability that it is more than n? This covers 50% probability, which is 0.5. So yes, this is true. Now we are supposed to verify option B. Okay, so let's verify option B. In option B, they are asking you what's the probability of Sn less than or equal to n plus root of n by 3, and this probability is given as 0.8413. We have to verify this. So the probability of Sn minus n is less than or equal to root of n by 3. If this root of n by 3 is taken to the denominator, it is Sn minus n by root of n by 3 is less than or equal to 1. Do you know how does this resemble? Sn is a normal random variable whose mean is n, and you have divided with the standard deviation of Sn, because what is the standard deviation of Sn? It is root of n by 3. This clearly resembles like x minus mu by sigma, where we replace with z. So this is same as the probability of z less than or equal to 1. So probability of z less than or equal to 1 means you can also write like this: probability of z less than or equal to 0 plus the probability from 0 to 1. So to the left side of 0, the probability is 0.5, because the standard normal random variable, and from 0 to 1, try to recollect, the approximate value is 0.3413. So and then overall it is 0.8413, which is close to what they gave, 0.8413. Yes, option B is also true. The answer for this problem are A, B and C. These are the right answers to the question. Let's look at this question. Consider R square with standard inner product. So he's talking about some inner product. U is given as AB, is a vector in R2 such that the inner product of U with 1, 2 is 2, and then with 4 minus 2 is minus 1. Then which of the following statements is true? So we don't know what is U, but when you take the inner product of U with 1, 2, it is giving you 2. If you take the inner product of U with 4 minus 2, it is giving you minus 1. So let's try to find the inner product of these two vectors. It will be A plus 2B. A plus 2B is given as 2. And then the inner product of U with this vector, so which is like 4A minus 2B, it has to be minus 1. So if you add them, so they cancel, this will be like 5A equal to 1, and the value of A is 1 by 5, which is 0.2. So you have A value, substitute here, you let B value, it is 0.2 plus 2B equal to 2. So from this, 2B is 1.8. It is 1.8, and from this the value of B is 0.9. So A is 0.2 and B is 0.9. Now I have the vector U, which is 0.2 and 0.9. What is the inner product of U with 1 minus 1? So 1 minus 1 inner product is, it is 0.2 minus 0.9, which is minus 0.7. This doesn't work. It is MCQ, only one answer is going to be right. So for the second option, if I take the inner product, it is minus 0.2 plus 0.9, which is 0.7. 3 by 5 is 0.6. This doesn't work. Inner product with option C, if I see, 2 into 0.2 minus 0.9 by 2. 0.9 by 2. So if you try to see how much is this is 0.4. If 2 also multiplies, it is 0.8 minus 0.9 whole divided by 2. This is not minus 6 by 5, something else. So the only option that is left is option D. It has to be right. You can verify that. If you try to take the inner product with this, 0.2 into minus 0.5, 0.2 minus 0.5 is minus 0.1, plus 0.9, which is 0.8. 4 by 5 is 0.8, it matches. So the answer to this problem is option D. They give a function which is e power x minus ax for x belonging to R, where a is greater than 0 as a constant. Which of the following statements is are true? So we need to verify all of them. So f of x is a local minimum at x equal to log a. If a less than e, then f of x is greater than 0 for all x belonging to the real numbers. F of x is a convex function in this interval. If a is equal to e, then the function has a local maxima at x equal to 1. Let me first check whether is this a convex function or not. What is f dash? It is e power x minus a. What is f double dash? It is e power x. Clearly e power x is something which is greater than 0. This indicates that f of x is convex. F of x is a convex function. So this is true, but since it's a MSQ, you have to verify each and every option. He says f of x has a local minimum at x equal to log a. So let me find the stationary point. E power x minus a has to be equated to 0. E power x is a. So from this you get the value of x as ln a. And at x equal to ln a, we clearly have the second derivative to be positive, because we said it's a convex function. For any value of x, it is positive. Even at x equal to a, it has to be positive. So this guarantees that it is a local minimum at x equal to ln a. It is not only a local minimum, since the function is convex, it is also a global minimum at x equal to log a. And then he says if a is e, then the function has a local maximum at x equal to 1. So first of all he says a is e. So when a is e, what is x? It is ln e, which is 1, that is x is 1. Just now we said that at x equal to ln a, where a is e, that means x equal to 1, the second derivative is positive, which guarantees a local min. Local max is wrong, so this is eliminated. Now we are left with option B. It says a is less than e, then f of x is greater than 0. Okay, so this is interesting. So let's see, at x equal to ln a, we are now confirming that it is a minimum, and it is also a convex function, you are saying, so it has to be a global minimum. So when you say it's a global minimum, let's try to find the value at ln a. So what's the value at ln a? It is e power ln a minus a into ln a. E power ln a is a minus a into ln a. So this is a into 1 minus ln a. Students, this is the minimum value. If I show that the minimum value itself is positive, then every other value will also be positive. I want to know when is this greater than 0. So look at this. When I say that minimum value itself is positive, then every other value will also be positive. So they said in problem that a is positive, so we are not having any problem with this. I want to know when is 1 minus ln a positive. So when is 1 minus ln a positive? You rearrange this: 1 greater than ln a to the base e, log to the base e. So from this, it's very clear that when e is greater than a, or when a is less than e, so we have this function to be greater than 0, this value to be greater than 0. When this value is greater than 0, when the minimum value itself is greater than 0, then every other function value would be greater than 0. So I can say that when a is less than e, our function f of x is greater than 0. How did I know that? First, I have calculated the minimum value. I'm seeing when is the minimum value greater than 0. I found that for a less than e, f of x is, the minimum value is positive, and minimum value is positive, our function is also actually positive. So for a less than e, f of x is greater than 0. Yes, this is true. The answers for this question are A, B and C. So let's proceed. A is a 5 cross 4 real matrix having the singular values as 6, 3, 1, 0. Consider the SVD, which is A equal to U sigma V transpose. Which of the following statements are correct? So when I see the sigma, the singular value 6, 3, 1, 0, there are three non-zero singular values, which confirms that the rank of the matrix A is 3. So this is going to solve you many questions. They want the dimension of null space of A. So the dimension of null space of A has a formula n minus rank of A. So if A, imagine A is a m cross n matrix, then the dimension of null space is given by n minus r. Here n is 4, 4 minus 3 is 1. Yes, this is right. And then dimension of R of A transpose is the same as the dimension of row space. The dimension of row space is directly equal to the rank of A, which is 3. Yes, this is also correct. The columns, okay, we will also find the dimension of the null space of A transpose. The dimension of null space of A transpose as a formula, which is m minus rank of A. Here m, if you compare, 5 is m, so 5 minus 3, which is 2. So the dimension of null space of A transpose is actually 2, but he says 1. This is wrong. The next thing is the column space of U spans R power 5. So first I thought it is column space of A. I thought they are talking about the column space of A. No. They are talking about the column space of U. It actually spans R power 5 itself. So you have to verify that. First of all, in SVD, do you know what is U? Since A is 5 cross 4, U is a 5 cross 5 orthogonal matrix. Orthogonal matrix. Now, if you are talking about orthogonal matrix, the columns are actually perpendicular. First of all, they are linearly independent and they are also perpendicular. And when you look at their length is 1. What information I need is, are they linearly independent? First of all, it's a 5 cross 5 matrix with 5 columns. Yes, they are all linearly independent. And we also know the orthogonal matrix det is not 0. So through that also you can confirm that the columns are linearly independent. So if you can confirm that the columns are linearly independent, the 5 columns will definitely span R power 5. So the column space of U spans R power 5 is the right answer. There is nothing wrong in this. Suppose if the question was the column space of A spans R power 5, then you have to check, and maybe it may not span because you have only 4 columns and the rank is 3. So it's not possible to span R power 5 with the help of columns of A. But here the question is about the column space of U. U contains 5 linearly independent columns. So definitely it spans R power 5. Which of the following are the subspaces of R power 3? So it's a MSQ. Now when I look at this, it's a vector where x plus y plus z equal to 0. This is actually representing a homogeneous system. The solutions to the homogeneous system will definitely form a subspace. There is nothing wrong in this. D is correct. Even I have no problem with A. I don't have any problem with B. If you want, you can verify there are some rules. So when do we say it's a vector space? Like you take 2 vectors from a set, you add it, the new vector should also be part of the given set. So a 0 vector should also be a part of the given set. If you take a vector called v1, then minus v1 should also be part of that. If you take a vector called v1, alpha into v1 should also be part of that. So A, B, verify that. And I have an issue with C, it is because of this square. It's like when I take the value of x as 1, then the vector will be like 1, 1, 1. So this value, like the whatever component is there, it is x square, this can never be negative. Yes or no? This can never be negative. So if this is part of the vector space, then minus 1, minus 1, minus 1 is never part of the vectors, like never part of the given set, because x square can never be negative. So through this simple logic, you can actually eliminate. And also, you cannot have a 0 vector here. When you say 1 x square, you can make this 2 fellow 0, but you can't make this 0. So 0 vector is not part of this set of vectors. This is not a subspace. So that's a nice way. You can set x, y as 0, then 0 vector. If x is 0, it's a 0 vector. So this doesn't satisfy, whereas the remaining options satisfy. So what are the answers? A, B, D are the answers for this. A, B, D.
Hello students, myself Ramesh Masuna. Now I am going to discuss about database management systems and data warehouse, the solutions given in the pre-GATE 2026. Here the first question given is, which of the following are typical tasks performing during the transformation stage of ETL? What is ETL process? Extract, transform and loading while building the data warehouse. In the ETL process consisting of data cleaning, okay, it is data cleaning, data integration, data aggregation, but encryption is not part of ETL. So answer for this question is A, B and C are the answers for the question. Second one, the normalization of 1NF relations to 2NF involves. So 1NF to 2NF involves the removal of partial functional dependencies. So it means from 1NF, if we remove PFDs, we can make the relation to be in 2NF. So removal of full dependencies not required. Removal of transitive dependencies are required in the second normal form to make it into third normal form. But question is 1NF to 2NF, removal of partial dependencies. And removal of multi-valued dependencies happened in the fourth normal form, right? So answer for this question is option C. Look at here. Consider the following student table given. The aggregate functions average of marks, count of mobile number on student table will present respectively. We know that aggregate functions ignores nulls. In a marks column, null is there, it is ignored. In the count of mobile number, null is there, ignored. Now count of mobile number will give you number of values in the mobile number column. 3 values are there. 3 is the count of mobile number. So that these two options are wrong. Next, average of marks. Average of marks is sum of values by number of values. How many values are summed? 3 values are summed. 250 plus 350 plus 300 by 3 we have to do it. So 250 plus 350 plus 300 by 3 will give you 300. So what is it gives you? 300. So A is the right, B is wrong. So correct answer is option A. We should know the point that aggregate functions ignores null. Null is not counted. Look at this question. Consider the following table instructor. Instructor table is given. Now question is, how many number of rows will be in the output after executing the below query? After executing the query, how many tuples in the output is the question. So what is the query? You look at, select instructor ID comma name from instructor where salary greater than 40,000. Okay, one by one we'll do it. First we'll select those tuples whose salary greater than 40,000. True, false, true, true, false, true. 4 tuples are selected, right? Okay. Next, group by instructor ID comma name. Means these 4 records to be grouped according to their instructor ID and name. Now look at instructor ID name 1201 LX and 1201 LX. Means these 2 records will form one group. Okay, these 2 will form one group. Next, 1203 Michael, 1203 Michael. Just I'll be underlining it. 1203 Michael selected and 1203 Michael. Okay, these 2 will form second group. Means how many groups are there? 2 groups. Again, come back to the question. Having is there. After groups are done, 2 groups are done, it is selecting some group with a condition count of distinct university greater than 1. Now, go ahead with the table. What are the count? What is the universities? Harvard, Harvard. Distinct universities are Harvard, 1. And that count is 1 na? Greater than 1 condition false, so that this group is not going to be selected. But when it comes to these 2 tuples, what are the count of distinct university? Cambridge and Oxford. So count of distinct universities 2, but condition is 2 greater than 1 na? Correct. So means this group is going to be selected. For this selected group, what it is finding in the output? Instructor ID and name. For this group, what is the instructor ID? 1203 and name is Mitchell. So 1203 and Mitchell is in the output of the query, right? So how many rows are there in the output of the query? Only 1 row is there in the output of the query, because only 1 group is selected. So answer for the question is 1. Which group is selected? This group. For this group, what is the instructor ID? 1203 and name is Mitchell in the output. So the number of rows returned by this query is 1 row. 1 row is going to be returned. Fine. Here it is given, consider a fact table. It is given a sales fact table having city, product, month, amount. It is mentioned city has 2 values, product has 3 values and month has 4 values. Based on that, aggregates are found in the fact table. Now question is, find the number of tuples in the output of the following query. What query is finding? Select city, product, month and sum of amount from sales fact table. Group by roll-up operation. What is roll-up operation? Roll up, reducing the dimensions. Okay, roll-up is going to reduce the dimensions. Means here it has to find the aggregates with respect to city, product and month. So with respect to city, product and also month, how many combinations are there? City has 2 values, product has 3 values, month has 4 values. If you group according to the city, product and month, how many groups are possible? 2 into 3 into 4, that is 24. 2 into 3 6, 4 is 24 groups are possible, 24 rows are possible, right? And when you roll up, you have to reduce 1 dimension. So means we have to find groups with respect to both city and product. How many values of city is there? 2. How many values of product? 3. So how many tuples are in the output? 2 into 3, 6 combinations are possible. Again roll up, drop the dimension, product. So with respect to city, if we group according to the city, how many groups are possible? 2 groups only. Why? Because only 2 city values are there. 2 groups are possible. So 2 rows. And again roll up, even this city is dropped, then you are going to get grand total. Means all together. The all together, how many rows are possible? 1 row possible. So total how many rows are there in the output of this query? 24 plus 6, 30 plus 2, 32 plus 1, 33. So means there are total of 33 rows possible in the output of this query, right? So answer for this question is 33. Look at, consider the following relation: student, SID, SNAME, marks, where SID is a primary key. Okay. What it is finding? Select count star from student S where not exists. What not exists operator requires? Not exists operator requires that inner query output is empty, then it is going to return true. because exists of empty false, not exists of empty true. So means not exists of empty set, it is going to return true. So because not exists operator is there, this inner query output should be empty. In order this inner query output to be empty, these conditions are always to be false. If conditions are false, this condition is false, then the inner query output is empty. Now what it is testing? For each student, it is checking the inner query with other students. Why? Because see, student S comparing with student S1. What is a comparison? The student SID in the outer query should not match with student SID in the inner query. Means it is comparing two different students. With what condition? Their marks are equal. If the two students, means the student in the outer query is matching with some student, some other student in the inner query, and their marks are same, it is giving the output. If it is giving the output, not exists of output returns false. It means it should not return any output. Means this condition should always be false. In order this condition to be false, what is the point here? The student in the outer query is comparing with some other student in the inner query, and those two students have different marks, the inner query is going to return empty set. If inner query returns empty set, not exists of empty is true, so that that student will be in the output of count. It means students having the same marks, two different students having the same marks, output you are getting. If two students have different marks, means the marks of a student in the outer query not matching with marks of any other student in the inner query, you are never getting any row in the output of inner query. So that empty set, that student will be in the output. So means it is going to find the students who have distinct marks, not the same marks. So number of students who have highest marks, wrong. Number of students who have least marks, wrong. Number of students who have distinct marks, right. Number of students who have some marks which are not null, wrong. So what is the correct answer for the question? Option C is the correct answer for the question. If we delete key 11, what is the impact on the below B plus tree? If we delete key 11, so if you have to delete key 11, just find where is a key 11. Key 11 here and also here. It is to be deleted from all the places where 11 is present. 11 is present in the leaf node, 11 is present in the internal node. So delete from both the places. Once it is deleted, now what is the question? What is the impact on the below B plus tree? What options are given? Oh, some mappings are given. Some what we can call balancings are given. So before I'll check with the options, first we'll delete and see. By looking this, what we can understand, the property of this B plus tree, right, is 5 left is 2, 3, 5 right is 5, 7, 8. Means left is less than, right is greater than or equal to. If 11 is deleted, look at here, how many keys are there? 3 keys. Minimum keys 3 by 2 upper bound. Means 2 keys should be there. Because 2 keys should be there, but 1 key na, so it is imbalancing. If it is imbalancing, what we can do? Because it is imbalancing, what we can do? We have to borrow the keys from siblings. But siblings having only 2 keys. Here also 2 keys only there. So no possibility. When no possibility, what we can do? This 17 you merge with this one. So you have to go with merge. If you merge it, this wing is deleted. If this wing is deleted, this should not be there anymore. So what will be the result entry? Root should have 19, right? 19's left is 5, 9, just only 5, 9. 5 left should be 2, 3, and 5's right should be 5, 7, 8, and 9's right is 9 and 10, right? And 19's right is, what is that? 19's right, 29, and 29. Now 9, 10, it is to be added with 17, na? It should be merged. It should be merged. So 9, 10 and 17. 29's left is 1923 and 29's right is 29 and 31. 29 and 31. Okay, this is a resultant tree after deleting 11 from the key, 11 from the tree. Now, what is the correct answer for the question? Now, question is, a node with value 11 is deleted from only leaf node and no changes is needed to the tree. But 11 is present in the leaf node as well as in the internal node. Whatever is there in the internal node is called copy. And if a key is deleted from the leaf node, its copy also to be deleted from the internal node. So, option A is wrong. Node with value 11 is deleted from both leaf and internal node and no changes is needed to the tree. It is to be deleted from both leaf and internal node, perfect. But it is mentioned no changes are needed, but changes are needed na? Because it is imbalancing. So, it requires to have a changes. So, B is wrong. Node with 11 is deleted from both leaf and internal node and the value 17 will be merged with 9, 10. So, check it. 17 is merged with 9, 10. Oh, it is a perfect option. Deleting key value 11 is not possible. You have to delete it and balance it. But there is no question of not possible. So, D is wrong. So, what is the correct answer for the question? Option C. Okay. Next question. Consider a data file containing 20,000 records stored on a disk with blocks are of size 2048 bytes. The key field is 40 bytes and the record pointer is 10 bytes. The number of blocks in the first level, secondary index. In secondary index, number of index records we have to create. Number of index records that we have to create is equals to number of records in the data file, because in secondary index, we have to create record for each record in the data file. Now, what should be the blocking factor for the index file? Block size by record size. Block size 2048 by index record size. Index record size is a key plus pointer, that is 40 plus 10. How much? 50. That is 2048 by 50. And it should be the lower bound, no fractions, because index is always fixed length records. So, it is how much? 2048 by 50. 2048 by 50, how much? Right, 204.8, right, point we have to ignore it, 5 4s are 20 and 40, 5 40s are 5 40s are. 40 is the blocking factor. If blocking factor is 40, the number of index blocks, simple, number of index blocks equals index records 20,000 by blocking factor 40, and block should be upper bound, but anyhow you are going to get the fixed value here. So, how much? 4 5s are 20, so means number of index blocks are 500. So, answer for this question is 500 is the correct answer for the question. Thank you.
So, hello everyone. So, let us have a discussion on data structures questions which we ask in pre-gate. See, this question based on binary tree concept. Just look at the data which they provided. There is a binary tree which is having in-order traversal as well as pre-order traversal. And by using in-order and pre-order traversal, if we construct binary tree, then in that binary tree, how many number of leaf nodes are there? So, first we need to construct a binary tree with the help of in-order and pre-order. You know how to construct, right? Just pick up the first key of pre-order sequence. Just pick up the first key of pre-order sequence and create a node of it and copy that key. Right, friends? Okay. Pick up the first key of pre-order sequence, create a node and copy that key. Afterwards, identify that key in in-order sequence. Identify that key in in-order sequence. Then there are some keys which are preceding root node 1 and there are some keys which are following root node 1. Keys which are preceding root node 1 comes under left subtree of 1, and keys which are following root node 1 comes in a right subtree of 1. So therefore, left subtree in order traversal contain 4, 2, 5, and right subtree in order traversal contain 6, 3, 7. Now please focus on 4 to 5. Yes, here it is 4 to 5 means they're in order 2, 4, 5, and this part comes under right subtree. So it is left subtree and it is right subtree. Clear? Again do the same process repeatedly. For 2, 4, 5, pick up the first key and create a root node for that, for the given subtree 2, 4, 5. Means for the given subtree 2, 4, 5 you have to create root node. Therefore, for the given subtree 2, 4, 5, root node is 2. So I am creating root node is 2. Afterwards identify 2 in in-order traversal. Yes, we are identifying 2 in in-order traversal. So if I identify 2 in in-order traversal, then there are some keys which are preceding 2, and there are some keys which are following 2. Keys which are preceding 2 comes under left subtree, keys which are following 2 comes under right subtree. So we can clearly understand that left subtree contains key is 4 and right subtree contains key is 5. Right friends, okay? Similarly for right subtree, pick up the first key of the pre-order sequence and create a node of it. Simply you can create a node of it. Identify that key in order traversal. Then 6 comes under left subtree of 3 and 7 comes under right subtree of 3. Right, okay. So in this binary tree, number of leaf nodes they are asking. So number of leaf nodes are exactly 4. Okay. So therefore answer to this question is 4 is the correct answer. Is it clear friends? Okay. Next, this question based on hashing concept where they are using linear probing to resolve the collisions. There is a hash table of size 10 which uses linear probing, right? If 7 keys are inserted with no rehashing, there is no rehashing concept in this case, then minimum possible number of collision is. So this is one of the trap question. So generally students are thinking, will they ask this type of simple question or not in the exam like that? No, definitely they'll ask this type of questions also to test the psychology of the students, okay? Last year also, as I mentioned earlier, they asked fixed sort algorithm question where they already provided elements in the ascending order. Then they ask what is the minimum number of swaps are required to sort them in the ascending order. If array elements are already in the ascending order, and if you pick up the last key as a pivot element, then obviously minimum number of swaps must be 0 only. In the same way here also, minimum possible number of collisions they are asking. Minimum possible number of collisions means if every key is hashed into distinct location, there is no collision occurs. So therefore answer to this question is 0. Okay. So to confuse the student, they will ask this type of questions friends. You please focus on this type of questions also. Next, it is based on circular queue concept. There is a circular queue of size 10. It is implemented using array. Initially rear is pointing to 7th index and front is pointing to 2nd index. So the number of elements which are present in the queue is, so it is a circular queue, just remember it is circular queue. So it is also 0 based index, it is 0 based index. So consider 0, 1, 2, 3, 4, 5 and then 6, 7 and so on, it is continuing. Where rear is pointing to 7th index, assume that there are some elements here, there are some elements where rear is pointing to 7th index and front is pointing to 2nd index. Front is pointing to 2nd index. Then the number of elements present in the queue is, simply what you have to do, whenever we know any interval a comma b, if you want to find number of elements in the interval, we can say b minus a plus 1. B minus a plus 1. Similarly, rear is pointing to 7th index. So therefore, you can say rear is pointing to 7th index here. Okay. So rear is pointing to 7th index. So therefore, we can take a rear minus front plus 1 by using this formula. So therefore, the formula is number of elements in the range front to rear is equals to, you can say rear minus front plus 1. So which is equal to 7 minus 2 plus 1. which equals to 6 elements are present. So clearly we are having 6 elements are present in the queue. Is it clear, friends? Okay. So answer to this question is 6 is the correct answer. So these are questions asked in data structures, and let us discuss questions based on algorithm subject. Okay. See, so this question have taken from the greedy method algorithm concept. Okay. So maybe they may ask question from greedy method also. That is the reason I have taken this problem, that is job sequencing problem. Look at this one. Given a set of n jobs, each job I has a deadline is a di and the profit is pi. Clear, friends? Okay, profit is pi. And each job takes exactly 1 unit of time, and at most one job can be processed at a time or scheduled at a time. So these are the constraints for processing job sequencing problem. Okay. In such case, which of the following is true? Actually, this question completely based on how job sequence algorithm is working. Clear, friends? Okay. See, a greedy algorithm that schedule jobs in decreasing order of their profits. Decreasing order of their profits. And place each jobs in the latest available slot before its deadline and always produces the optimal solution. It is a general principle to implement the job sequencing problem. That's why the statement is true. Okay. The statement is true. Second statement, the problem can be optimally solved using dynamic programming in order of n square time. No. This problem we can solve by using dynamic programming, but dynamic programming will take time complexity something like order of n into w, where n indicates number of objects, w indicates knapsack size. Okay. So it cannot be order of n square. Ignore that. Sorting the jobs by increasing deadlines and scheduling them greedily always gives optimal solution. No. So job sequencing problem do not depends on the deadline, friends. Okay, it all depends on the arranging jobs in the decreasing order of their profits. That's what is not correct. If profits are equal, it means that two jobs are having same profit. Okay, and scheduling jobs by earliest deadline first gives an optimal solution. Obviously, right? If two jobs are equal, then whichever jobs is going to finish earlier, you have to schedule that job. Okay, you have to schedule that job so that it is taking optimal solution, which is also correct. Clear? So therefore, for this question, A and D both are correct, remaining all are false. Next, this question based on full binary tree. Consider a full binary tree in which each internal node has exactly 2 children. It is one of the definition of full binary tree. Full binary tree means every internal node is having exactly 2 children. In such case, the number of internal nodes in the tree is 31. Then the number of leaf nodes in the tree is, see, there is a relationship between number of internal nodes and number of leaf nodes. For example, if I consider a binary tree, so clearly it is a full binary tree because this internal node is having 2 leaf nodes. Is it clear, friends? Okay, every node is having 2 children. That's why that is a full binary tree. In this full binary tree, number of internal nodes, if I consider number of internal nodes is equals to 1. How many number of leaf nodes are there? Number of leaf nodes is equals to 2. It means there is a relationship between number of internal nodes and leaf nodes here. Okay, let us consider one more example. Of course, it is also full binary tree because every internal node is having exactly 2 children. Okay, every internal node is having exactly 2 children. So number of internal nodes are 2 and number of leaf nodes are 3. So by observing this one, there is a relation between internal nodes and leaf nodes. Number of internal nodes must be number of leaf nodes minus 1. Okay, so here they provided number of internal nodes are 31. Then I can compute number of leaf nodes. So number of leaf nodes always number of internal nodes plus 1. So 31 plus 1 that equals to 2, 32. Clear, friends? Okay, number of leaf nodes always equals to number of internal nodes plus 1. This question based on directed acyclic graph having 8 vertices. So you try to understand, for example, if you have 3 vertices u, v, w. If you want to make it a directed acyclic graph, suppose if u to v an edge direction is possible, then we cannot take an edge direction from v to u. We cannot take an edge direction from u to v. if u to v is edge direction is possible, we cannot take edge direction from v to u. If you could take like that, it is forming cycle. It is not a directed acyclic graph. Okay, so based on that properties, please understand this problem. So this vertex u is having two possibilities. Yeah, let me draw like this because it is not working properly. Let me take it. Suppose if I draw an edge from v to u, I cannot draw edge from u to v. Is it clear, friends? Okay, so with respect to v, I can draw edge from v to u, and also I can draw edge from v to w. V to w. So if I draw edge from v to w, I cannot draw edge from w to v. So with respect to v, we have two possibilities, right? Two possibilities. One is drawing edge from v to u, another edge from v to w. Next, with respect to u, since you already drawn v to u, we cannot draw edge from u to v. There is only one possibility, that is equals to v to w I can draw. Clear, friends? Okay. If we draw an edge from v to w, therefore number of possibilities here, only one possibility is there. Is it clear, friends? Okay. So similarly, with respect to w, I cannot draw edge from w to u because it is forming cycle, and for w also we cannot draw an edge from w to v, it is forming cycle. It means that what I am trying to say, for example, if I have v1, v2, v3, v4, for example. So in order to make directed acyclic graph, v1 can have edge from v1 to v2, v1 to v3, v1 to v4. Right, friends? Okay. Means v1 can make edges with remaining three vertices. Okay. But what about v2 means? v2 cannot have edge from v2 to v1. But I can draw edge from v2 to v3. I can draw edge from v2 to v4 without forming any cycle. So therefore, there are two possibilities at v2. Since v3 already connected to v2, v3 already connected to v1, there is only one possibility, v3 to v4 without forming cycle. Okay, that is one possibility. v4, there is no possibility, friends. Okay, because it's like graph do not contain cycle. Therefore, if you have four vertices, it is 0, 1, 2, 3 like this. If you have three vertices, it is taking 0, 1, 2. In general, if you have n vertices, it is taking 0 plus 1 plus 2 plus up to so on n minus 1, which equals sum of n minus 1 natural numbers n into n minus 1 by 2. Okay, sum of n minus 1 natural numbers, simply actually sum of n natural numbers is n into n plus 1 by 2, right? In the place of n, we can replace n minus 1, n into n minus 1 by 2. So here they provide 8 vertices, that's why 8 into 8 minus 1 by 2, that equals to 28. So the maximum number of edges that can have is 28 edges it is having. Is it clear, friends? Okay.
In this question, it has been asked what is the value of b0 plus b2 at the end of the given code. In this code, you can see that there is a function defined named as tricky, and this portion which I am right now marking is the main code from where the execution will start. Now you just see A and B are the lists written in the square bracket. So for our understanding, I am showing these two lists are stored in the memory somewhere as objects. This is a list object, and A, this reference A refers to this list. Similarly, B is referring to another list, that is object of list class, which is containing 5, 6, 7, 8. Now what we are doing in this line, you watch, tricky A comma B means we are passing references. We are not passing the entire object which contains 4 elements each. We are passing references to our function tricky. Then when this tricky function starts, just check, when the tricky function starts here, you know, this reference first A is equal to the reference A of the main. And this B is a new reference which is equal to the reference B of the main. That means there are two new references created. The first reference A, which is the parameter of the tricky function, refers to the original object where A is referring. And the second parameter B I'll pinpoint that again. Second parameter, this B is a new reference, local reference, which refers wherever the original parameter or original reference B is referring. So the B refers to this object. Now inside the code, it has been written that A0, just check, inside the code, inside the function, it has been written that A0 should become equal to B2. That means this element A0, I am just putting the indexes, A0 should become equal to B2. Check, B2 is 7. So A0 will clearly change and A0 will become 7. As you all know, list object is mutable. You can change the values of the list. Now the next line executes in the function a comma b should become equal to b comma a. This is clearly swapping of two variables a and b. So a refers wherever b refers and b refers wherever a refers. They are interchanged. But please try to understand which a and b are interchanged. The local a and b are interchanged. Tricky is now having its own parameter a and its own parameter b. Agreed that a and b are referring to the original objects, but when we are swapping a and b, then those temporary parameters are getting swapped. What it means is that this reference a will now no more point to where the original a was pointing, because we are swapping a and b. Hence a will now refer to wherever b refers and b will refer wherever a refers. So what we will have is, we will have in our new picture, you see this is the original b, this is the original b shown in white color, and the temporary b, the parameter b now refers wherever a refers. You watch, what has got swapped is parameters a and b have got swapped, not the original references a and b which main had made for the objects. And after that, you know, the function ends. This function is now ending without returning any value, of course. And then the main resumes. And after main, you see, after this tricky call, there is nothing. Absolutely nothing. So main also ends. Now finally they are asking, what is the value of b0 plus b2? And b0, you observe, now there is a trap here, gate trap. One might feel that a and b got swapped. So one might feel b0 plus b2 means now we should take this b because they got swapped. No. The function has finished. As the function has finished, these parameters are destroyed, which I had shown in yellow. You know, these were local parameters. They live only as long as function runs. And when we are back to main again, after the function ends, when we are back to main, we still have a pointing to original list, which is, of course, I agree, which is 7, 2, 3, 4 now. Remember, a0 got changed. And b is still referring to the original list, which is 5, 6, 7, 8. And they are asking at the end, what is the value of b0 plus b2? b0 plus b2 has to be 5 plus 7, that is 12. So C is the correct answer. If you would then make if you go into that trap, thinking that b and a got swapped, so when the tricky ends, you might feel that this is b and this is a because they got swapped. And you will end up giving the answer that b0 plus b2 is 10. You would then think that 10 is the correct answer. No, b and a got swapped temporary inside the function. Parameters were swapped. But when we came back from the function, a and b are still referring to wherever they were referring. Okay, this was the first question. Second one, what is the value returned by the function called f7? So this function, you know, f has been called with the parameter 7, n is 7. And you can see that there are two recursive calls in each execution of f. And I have a habit of showing such functions as a tree-like diagram, so that f7 calls one of its recursive calls and f7 calls another recursive call. Then each one of them calls again two recursive calls. So it's like a binary tree I draw. So I am showing the execution using a chart here. Fn starts with n equal to 7. Now, when we check this if inside the function, n not equal to 0 is true, 7 not equal to 0. So this statement is executed. And I literally have a habit, even in GATE exam, I have a habit of writing that statement. Return on the scribble pad which is given to us. Return 1 plus f of 7 by 2. N by 2 is written. 7 by 2 is 3 because it is floor division, plus 7 by 3 is 2. Again floor division. Correct? 3 2s are 6. So now there are two recursive calls, you see. First one is f3. So I will show it like this. Fn gets called again with n equal to 3. Now when n is 3, you observe the function reinitiates with n equal to 3, and you observe that n is still not 0, 3 is not 0. So this line runs, which is return 1 plus f of 3 by 2 floor division, which is 1, plus f of 3 by 2 is 1, plus f of 3 by 3, which is also 1. Correct? 3 by 2 is actually 1.5, but it is floor division. Now this is a recursive call. So f1 gets called. I will show fn is now running with n equal to 1. Just scroll up. When n is 1, again n not equal to 0 is true. So this line runs, which says it should return 1 plus f of 1 upon 2, which is 0, floor division, and 1 upon 3, which is also 0. Now this f0 gets called, recursive call fn, where n is 0. Observe, when n is 0, else will run, which returns 1. That means each time now, when the function is called with any value other than 0, correct, not equal to 0, then return 1 plus f of n by 2 plus f of n by 3 will run. But when it is called with value 0, then else will run and the function will return 1. So this function ends because it is returning a meaningful, a concrete, a primitive value 1. So this f of 1, f of 0 call has got evaluated to 1. Obviously this is also a recursive call f0. It will also get called, isn't it? But you don't have to evaluate it. f0 anyway you know is 1. Now this function f of 1, just check, we are now returning to f of 1. F of 1 will now calculate 1 plus 1 plus 1 and return 3, and it will end. So f of 1 has got evaluated to 3. We are back to the calling function. The calling function was f of 3. This function f of 3 is now resuming, it will call f of 1. This recursive call is pending, but you don't have to again reinitiate it and go through, because f of 1 we have already seen is evaluated to 3. So obviously the second f of 1 will also get evaluated to 3. Then this function f of 3 will return 1 plus 3 plus 3, which is 7, and it will end. So obviously 7 will be returned back over here at the call. This value is now 7, but f of 2 is remaining. Okay, and we don't have f of 2 call anywhere. So let's call f of 2, f of n, where n is 2. What is it going to do? It's going to say I will return 1 plus f of n by 2, which is 1, plus f of n by 3, which is 0. I am executing the if part. But then we know f of 1, isn't it? F of 1 is 3. You observe this. F of 1 was 3. So we will not go through all the process of executing f of 1, and f of 0 is anyway 1. Then this function will execute 1 plus 3 plus 1, which is 3 plus 1, 4 plus 1, 5. So this f of 2, after this function ends, evaluates to 5. So 7 plus 5, 12 is the final answer returned by, 12 plus 1, 13. 1 plus 7 plus 5, 13 is the final answer returned. So the answer is A. Okay. Next question is, what is the relation between final value of variable C and initial value of variable B in the given Python code? So you can see in the options C is equal to log b to the log of b to the base 2. So they they are asking relation between C and B. Okay, and I think all the options include log. Right. Now, it is also given the initial value of B is in the form 2 raised to x, where x is any positive integer. That is also made very clear. So, B might be 4, 2 raised to 2. So, x is 2. B might be 16, 2 raised to 4. That is x is 4. Okay. Then the code is given. They are asking when this code ends, what is the relation between C and B? You can see here actually, B by 4 has been done. B is equal to B by 4. Okay, and you are all algorithm, you have learned algorithm subject where we analyze the time complexity, and there is a while loop till B reaches 1. It is B greater than 1, this loop will repeat, and B is repeatedly divided by 4. So it has to be log of B to the base 4. Either this option or this option. This is ceiling of log of B to the base 4. Anyway, let's not assume anything. Very quickly, we can take some value of B and execute this. Okay, so what I will do is, in my first check, I will take B as 4. That is 2 raised to 2. Correct? So B is 4 I have taken. See, x, 2 raised to x. X is a positive integer. So I have taken x as 2. So 2 raised to 2, 4. Correct? Now, let's execute this. C is 0 initially. Then, while B is greater than 1 is true, because 4 is greater than 1, then B will become B by 4. That means B will become 4 by 4. Correct? Where B will become 1. And then C will become C plus 1. That means C will become 1 because C was originally 0. Okay. Now we are back to the while loop. We will check, can we repeat the while loop? But while loop can repeat only while B is greater than 1. But now B is exactly 1. So the while loop should break. It is no more greater than 1. Okay. So now after this execution of the while loop, do you have this option correct? You just see or this option or this option. Some options, might get cut, might get really deleted. You can see if this option was correct, A option was correct, then C is 1 here. I'll rewrite it. C is 1 and original value of B is 4. They are asking relation between C and original value of B. Now, if this option A has to be correct, then 1, that is C, should be equal to log of 4 to the base 2. But we know log of 4 to the base 2 is 2 and 1 equal to 2 is false. That means C cannot be equal to log of 2 to the base, log of B to the base 2, and C cannot be equal to log of B to the base 2 plus 1 also. Correct or not? Because if we take that option D, let's say, I'll rewrite these values. See, at the end we had C equal to 1 and original value of B was 4. Now, C equal to log of 4 to the base 2 plus 1. But we know log of 4 to the base 2 is 2 plus 1. This is 3 and C is 1. So, final value of C and original value of B do not have this particular relation. So A and D are dropped. Taking B as 4, we took B as 4 and it is not anywhere related to log of original value of B to the base 2. Okay, I'll just erase this. So the only options pending now are C and B. Let's see, C and B. So for doing that, what I will do is I'll take B, value of B as 16, 2 raised to 4. 16. Okay. Now let's execute this for 16. C is initially 0. B is greater than 1. 16 is greater than 1. So B will become B by 4. So B will become 16 by 4. B is 4. Then C will become 1 because C is C plus 1. And we are now going back to the while loop. Now observe that B is 4 latest value and B is still greater than 1. So this line will again run. B will become B by 4, 4 by 4, that is 1, and C will become C plus 1. Second execution, C will become 2. But next time, this while loop is going to break because B should be greater than 1 for executing the while loop. Now just observe C is equal to 2. And what was the original value of B? 16. So, is this option sounding to be correct? C, that is 2, equal to log of 16 to the base 4. You know log of 16, 4 square is 16, isn't it? So 2 is this value, correct? So 2 is equal to 2. So option B seems to be correct. Let's see option C also. Okay, what is option C saying? I'll rewrite the values. B got to be 1, C got to be 2. After the end of this code, these were the values. So is C equal to, that is 2 equal to ceiling of log of original value of B, 16 to the base 4. What is log of 16 to the base 4? It is 2, correct? 4 square is 16. So 2 is equal to ceiling of 2. Ceiling of 2 is 2. It is the next integer which is nearest to whatever you have written in the parameter. So 2 equal to 2. So even this option seems to be correct, both options. Then there is a tie between the two. I mean, then how will you settle this? With 16 you have got two options seem to be correct. Then ceiling will be used, you know, that ceiling function only when we get some floating point number there in the ceiling function. So what you might do is, you might take B as 2 raised to 5, which is 32. You know why we have to choose this value? Because log of 32 to the base 4 won't be an integer. See, 4 square is 16 and 4 cube is 64. Indeed, if you actually calculate log of 32 to the base 2, you know, this can be written as log of 2 raised to 5 to the base 4, which means this is 5 log of 2 to the base 4. And you know, this is nothing but 4 raised to half. So it comes out to be 5 upon 2 into log of 4 to the base 4, which is 5 by 2, which is 2.5. Of course, I am not teaching logarithm, or this is not the maths class, but why I have chosen this is because you see that in this particular size, you know, B, we will not get log of B to the base 4 as integer, we will get 2.5. Then that ceiling will be open and we can then judge whether any of the options are correct between B and C. So let's start the execution. C is 0, then while is true, 32 is greater than 1, then B will become 32 upon 4, which is 8. 8 4 is 32. Then C will become C plus 1, C is 1. And we go back to the while. While can repeat because B is greater than 1, 8 is greater than 1. So second execution, that means now B is becoming 8 by 4, which is 2, and C is becoming C plus 1. C plus 1 means 2. Second execution got, now when the while repeats, it can still repeat because B is greater than 1. Observe B is 2. So the third execution of the while loop, here goes, B becomes 2 by 4, that is 0. Floor division it is, 2 by 4, it is 0. And C becomes C plus 1, that is 3. Okay, and now this loop will finish. This loop will finish, you see, because B has become 0. Okay, now C is 3 and original value of B was 32. Just check. C got to be 3 and original B was 32. They are asking relation between C and original value of B. Correct. Now, is option B correct? If option B has to be correct, then 3 has to be equal to log of 32 to the base 2. Or check the option B. There is no ceiling function. Log of 32 to the base 4 is equal to 2.5. And these two quantities don't match. Correct. You can see option C has to be correct because option C is whether C, that is 3, is equal to ceiling of log of 32 to the base 4, and we saw that log of 32 to the base 4 is 2.5 and ceiling of 2.5 is 3. Correct. So option C is correct. Just check. This question was bit tedious, But actually, you can go with your gut feeling that b upon 4, as we have learned it in algorithm analysis, given some initial value of b until b reaches 1, we are continuously dividing b with 4. So it has to be one of these two options. Log to the base 4, not log to the base 2. That's it for these questions. Thank you very much.
Hi students, in this AI questions, the first question is what we have in Bayesian belief network. So it can give the exact marginal probabilities. The first statement is correct. And the second statement, this likelihood weighting, it comes under approximate inference, but not exact inference. Even variable elimination is also comes under approximate inference. We cannot confirm that it runs on polynomial time. Yeah, coming to option D, the Gibbs sampling belongs to the class of Markov chain mechanism, and Gibbs sampling comes under approximate inference. So we can confirm option D is correct and also option A is correct. Okay. And see this, in the first statement S1, what we have S1 here, S1 is P implies negation Q, and we have some conditional property. By using conditional law, what we can say, A implies B can be write as negation A or B. Negation A or B. So from this, I can say this is negation P or negation Q. By using De Morgan's, we can write negation of P and Q. So if you observe the statements S1, S2, S3, so these S1, S2, S3, all three are equivalent. So you can confirm the answer S1, S2 is equivalent, and also S1 and S3 are equivalent. Okay. And the answers whatever I am giving, they are the final answers. Even if there is any variation in key also, you don't bother. Just analyze yourself. These are the correct answers. So in this game tree, the min value carries from 3, 6. From these two utilities values, the min comes to 3 here. 4, 2, the min comes to 2 here. And maximum of 3 and 2 comes to 3 here. And the first statement is, the minimax value node B is 3. Yes, it is a true statement. And the minimax value of node C is 2. Yes, the second statement is also true. The minimax value at node A is 4. At node A is not 4. This statement C is false. And max will choose the right subtree. Actually, the max came from the left subtree, that is from the node B, not from right subtree. So option D is also wrong. So we can confirm A and B are correct answers to this question. And let us see the next one. So in this A star algorithm, if you go to the first node, that is source node, and the source node initial score is F score is 5 here. Let me write the sequence of exploration. The sequence of exploration. When you are taking the sequence of exploration, the first node comes to S here. After S, we have A and B. And B F score comes to 3 here. And A F score is 6 here. So the next exploring node, F score is minimum B. So let us explore B next. And after going for exploration, if you take C, it comes under 5 plus 4, 9. Yeah, C F score comes to 9. So in the open list, we have A and C. Hence, we are going to explore node A, minimum F score it has. So SBA we can get. My dear, if you go to the options, so SBA in this sequence only option A is available. So we can break it simply and you can proceed in this way and you can confirm answer is option A. The sequence of exploration is SBA, C, D, G like this. Okay. And see this question, in this question, the given statement is consider be like this. So all vehicles we are talking about. So all vehicles except electric, they are going to be heavy. So in that statement, different options are available. All vehicles are heavy except electric, which means that in this statement, we are not talking about all vehicles. We are talking about the vehicles which are not electric. Yeah, if the vehicle is not electric, then we can say it is a heavy vehicle. And what is a contrapositive statement to this? The contrapositive statement something like this. A implies B, we can take it as negation B implies negation A. You can also say like this, if the vehicle is not heavy, then we can say it is electric vehicle. Yeah, these both statements are logically equivalent. Okay, in this scenario, we can say, yeah, if the vehicle is not electric, then it is heavy, yes. And you can also say that the contrapositive statement, if the vehicle is not heavy, then it is electric. Yeah, this S4 statement is also true. Coming to S2 and S3, here, if the vehicle is heavy, we are not talking about heavy vehicles, we are talking about vehicles which are not electric actually. That is the reason S2 is not appropriate. And we are speaking about the vehicles which are not electric. So this S3 statement is speaking about electric vehicle. So S2 and S3 are not appropriate. You don't bother about options. Correct answers comes to S1 and S4. S1 and S4. Let me correct like this. S1 and S4 are the correct answers. Okay, got it here.
The given question is, you are given a data set with 3 features x1, x2, x3. After mean centering the data, the covariance matrix of the features is 410, 132, 025. The total variance present in the data set is. This is a simple question, and whenever a data set with a certain features, a certain number of features is available with you, then its variance can be calculated in 2 different ways. In both the ways, you need the covariance matrix. In the covariance matrix is always a square matrix, and in that covariance matrix, if you consider the diagonal elements corresponding value summation, that is nothing but mathematically the trace. So a trace of the covariance matrix gives the variance. The important point here is trace of the covariance matrix. gives the total variance. So accordingly, its value is 4 plus 3 plus 5, which is equal to 12. So 12 is the answer, and even if you are having the covariance corresponding eigenvalues, the covariance matrix corresponding eigenvalues summation will also gives you the same value. So even without giving the covariance matrix, if the eigenvalues are provided to you, then that eigenvalue summation is also, it also gives you the total variance. Next question. A regression tree is trained to predict house prices. It achieves near zero error on the training set but performs poorly on unseen data, indicating overfitting. The team wants to reduce overfitting by applying a regularization strategy specific to decision trees. Which one of the following is a valid regularization action for a regression decision tree? Option A, increase the maximum depth so the tree can capture more detailed patterns in the training data. And option B, decrease the minimum number of samples required at a leaf node so the tree can create finer splits. And option C, apply post pruning, for example, cost complexity pruning to remove splits that do not improve generalization. And option D, change the split criteria from mean squared error to mean absolute error while keeping the tree fully grown. So here there is a regression tree, which means the target is in the data set, your target is numerical in nature. And what is the behavior it is showing? On the training data, the tree is giving almost zero error, and on the unseen data, its performance is poor, such that it is an overfitted model. And the team wants to reduce it by applying some regularization method. What do we mean by regularization in decision trees? That is the question. Option A, the increasing the maximum depth regularizes the model. The answer is it correct or not? If we increase the depth further and further and further for a model, what happens is every leaf node or every data example ends up in a leaf node. That means that worsens the scenario whatever you are having. That means already it is an overfitted model, so that becomes a super overfitted model, such that your problem will not be solved. So option A is not a correct statement. Option A is incorrect. And decreasing the minimum number of samples required at a leaf node. Let us say at this stage, for example, it is having 20 data examples in a node. Let us say in a node, if I am having 20 data examples, then I will take the average of those 20 data examples and I am able to convert that into a leaf node, 20 or less than 20. If I would reduce it further, that means the arrived data examples are, let us say, 5 or 6. Then automatically the depth increases. Then there is no difference between option A and option B. Until you receive 5 data examples in a node, that node cannot be converted into a leaf node, such that the depth further increases. Such that it worsens the scenario. It becomes again, and the overfitted model will not be converted into a good fit model. So this is also not a regularization idea for a overfitted model. And apply option C, apply post pruning, such as cost complexity pruning, to remove the splits that do not improve generalization. So this is a post pruning is an idea where we will experiment with the existing splits and we will merge certain at the bottom level, beginning from the bottom of the tree. we will merge the splits and measure the performance. If after merging and before merging, if the performance is there is no considerable change in the performance, then we will remain with the merge. Why should we unnecessarily increase the depth of the tree without better performance? Right, without it getting a good performance, such that this post pruning idea comes under regularization. So merging the from the bottom level, merging level by level and checking the model performance, and if it is definitely it gives a model which converges to a good fit, such that option C is a correct statement. Change the split criteria from mean squared error to the mean absolute error while keeping the tree fully grown. First of all, we will not consider fully grown trees practically. That is first aspect. And another important aspect here is mean squared error and mean absolute errors are not the splitting criteria. The splitting criteria in general in regression trees would be standard deviation reduction. Of course, there are certain methods like that, but the mean squared error and mean absolute error are not the splitting methods, are splitting criteria, such that option D is also an incorrect statement. Option C is correct answer. Next question. Select all the correct statements about evaluation metrics for binary classifiers. Option A. If you raise the classification threshold, the model will typically predict fewer positives, which tends to increase precision and decrease recall. Option B. In precision recall curve, the x-axis is false positive rate and the y-axis is true positive rate. Option C. If a model has area under the curve is equal to 0.5, it means the classifier is perfectly accurate on a balanced data set. Option D. When the positive class is rare, accuracy can be misleading and metrics like precision, recall and PR area under the curve, PRAUC, are often more useful. Related to the evaluation metrics that we use in classification, we need to identify which statement is correct. Option A. If you raise the classification threshold, that means on increasing the threshold value from its default 0.5, what happens is the model will typically predict fewer positives, which tends to increase precision and decrease recall. Let us say the default value is 0.5 and I am increasing it to 0.8. Then the model predicts only the data examples whose corresponding sigmoid function output sigma of z is greater than 0.8 will be predicted as positive. Earlier, anything above 0.5 would be predicted as positive. Whether it is true or false, that is a different story. But as far as the prediction is concerned, anything above 0.5 would be considered as positive in a default setup. And if we increase the threshold, so the model will, if you raise the threshold, then the model will typically predict fewer positives. Obviously, anything above 0.8 would be predicted as positive and everything below 0.8 would be predicted as negative, such that the positive predictions will decrease and negative predictions will increase. Right. So, what is its impact on precision and recall? So, what is precision? Precision is equal to, with respect to positives, precision is equal to true positives divided by true positives plus false positives, and recall is true positives divided by true positives plus false negatives. So, what is happening here is on increasing the threshold from its default value, the number of positives are decreasing. So, as a consequence, false positives will also decrease. False positives will also decrease and the precision increases because of that. And in recall setup, false negatives, if false positives decreases, false negatives will increase because the total negatives are increasing in this scenario, such that the false negatives will obviously increases, and as a consequence recall decreases. So because of the increase in the threshold level, precision increases and recall decreases. So this is what exactly given in option A, such that option A is correct. Next, coming to option B, in precision recall curve, x-axis is false positive rate and y-axis is true positive rate. This is an incorrect statement. X-axis is precision, y-axis is recall in precision PR curve. That is, for x-axis false positive rate and y-axis true positive rate is correct in the scenario of receiver operator characteristic curve, ROC curve, but not in PR curve, such that option B is an incorrect statement. Next, coming to C. If a model has AUC is equal to 0.5, it means the classifier is perfectly accurate on a balanced data set. AUC is equal to 1 gives you always the best performance. The model with the highest AUC will always be considered as the best model, and AUC is equal to 1 is an ideal scenario. Whereas AUC is equal to 0.5 will be considered as a random classifier. AUC is equal to 0.5. AUC is equal to 0.5 gives a random classifier, such that option C is also an incorrect statement. C is also incorrect. Option D. When the positive class is rare, accuracy can be misleading, and metrics like precision recall and precision recall AUC are often more useful. The main reason, that means in our real world scenarios, there are so many examples where one class will completely dominate the other class. This scenario is called class imbalance. If you are having class imbalance, one finest example is credit card fraudulent transaction detection. Fraudulent transactions are very less when compared with legitimate transactions, right? Such that this class imbalance is very frequently occurs in real world scenarios. Another example is cancer prediction. Cancer case, out of 1,000 people, cancer will exist hardly in 1 or 2. The positive will exist in 1 or 2. Such that cancer positive rate is very less compared with, very less compared with negative rate. This is imbalanced data set, and whenever we are having imbalanced data set, accuracy is not a perfect metric. Precision recall and the combination of precision and recall like F1 score and even precision and recall area under the curve leads to a better they give better visualization or better performance visualization, and they are considered as better evaluation metrics than accuracy and error rate. such that when the positive class is rare, not only positive class, any one class is rare, that is called class imbalance. And in class imbalance, precision and recall PR curves are the most widely used evaluation metrics, such that option D is correct statement. So the correct answer is, answers are A and D. The given question is, a ridge regression model without bias is used, that is y hat is equal to wx. You are given the data set with 3 data examples 1, 4, 2, 5, 4, 6. The ridge objective is minimize w with summation I is equal to 1, 2, 3 yi minus wxi whole square plus lambda w square with regularization parameter lambda is equal to 3. Find the ridge estimate w. Answer as a decimal rounded to 2 places. Here, in the problem statement, a data set with 3 data examples is given to us, a single feature x and its corresponding y, and for 3 data examples, with the 3 data examples we have the data set, and the regularization parameter lambda is also given to us. Lambda is equal to 3. And an important point about the model is, the model does not have any bias. Bias b is equal to 0. So without bias, w, the model parameter w is given as from ordinary least squares method. By using ordinary least squares method, the optimizer w can be given as summation I is equal to 1 to m xi multiplied with yi divided by summation I is equal to 1 to m xi square. We know that. This is without bias w expression. Here we have without bias and regularization parameter lambda. Under such case, without bias, that means b is equal to 0, and we have regularization parameter, that is ridge regression. The expression is telling to you, the model expression is telling to you lambda w square is there. So under that case, under that ridge regression scenario, your weight w is given as same as this expression, that is summation I is equal to 1 to m xi multiplied with yi divided by summation I is equal to 1 to m xi whole square plus lambda. So just in the denominator, the regularization parameter will appear. So that means when compared with this w lambda would be a smaller value. That is what regularization means, a slight penalization by your regularization parameter. Right. So now we have xi and yi values for m is equal to 3 data examples are given to us. So those are 1, 4, 2, 5, 4, 6. 1, 4, 2, 5, 1, 4, 2, 5, 4, 6. Right. So this is x, this is x, and this is y. So the numerator would be, that is x multiplied with y, 4, 2 multiplied with 5, 10, and 6 multiplied with 4, 24. So that would be, the numerator would be summation of these values. So that summation is equal to 38. and then we need xi square. So x square, 1 square is 1, 2 square is 4, 4 square is 16. So this value is 21. To this, you need to add the lambda value. So 21 plus lambda is equal to, that lambda value is given as 3, such that it is a 24. Therefore, in this for this specific data set, here W lambda is equal to, numerator is 38 and denominator is 24. So this value is approximated to 1.588, and rounding it off to 2 decimal places, it would be 1.59. So this is 1.588, such that the correct answer is 1.59. The given question is, consider an SVM that uses the non-homogeneous polynomial kernel of degree 4. Kernel of x comma z is equal to x transpose z plus 1 to the power 4, where x comma z belongs to R2-3 space. This kernel corresponds to an implicit feature transformation that includes all polynomial terms in the input components whose total degree is at most 4. Determine the dimension of the transformed feature space. In algorithms like support vector machines, in order to have a linear separation, the popularly used technique is kernel trick. What happens in kernel trick is, the lower dimensional data has been transformed into higher dimension, and the dot product of every data example in the data set will be taken with every other data example in the data set. If I am having 100 data examples, then first data example with second data example dot product, first with third, first with fifth, second with third, second with fifth, second with sixth, like that. Every data example dot product is required with every other data example. And in kernel trick, rather than transforming the entire data set into higher dimensional space and then getting their dot product, the kernel function is able to give the resultant of the dot product directly. So in that way, it makes the things simpler. The kernel trick, the kernel function makes the things simple. So here a fourth order non-homogeneous polynomial kernel is given to us. X and Z are two randomly taken data examples which are initially belong to 3-dimensional space. So what I am taking here is the non-homogeneous polynomial kernel order is 4, that is taken as P, and N, that is the initial feature space, or the initial number of features are 3. What would be the transformed feature space size? That means it is transformed into at most. That means if I am considering all the 4 at most corresponding terms, then what would be the possible highest possible transformed feature space that needs to be obtained? That can be given by the transformed feature space size of transformed feature space. Transformed feature space is equal to directly it can be given as N plus P combinatorial P. So that is equal to simply 4 plus 3, that is 7C4. So that value is equal to 7 factorial divided by 4 factorial multiplied with 7 minus 4, that is 3 factorial, such that its value is equal to 7 multiplied with 6 multiplied with 5 multiplied with 4 factorial divided by 4 factorial multiplied with 3 factorial. 4 factorial, 4 factorial, and 3 factorial value is 6, such that it is equal to 7 multiplied with 5, 35. So the size of the transformed feature space is equal to 35. So a 3-dimensional space can be transformed into a 35-dimensional space if you consider all the terms that are obtained by expanding this non-homogeneous polynomial function. So the answer is 35. The correct answer is equal to 35. Next question. In Fisher's discriminant LDA, SW denotes the within class scatter matrix, that is the variation within each class, and SB denotes the between class scatter matrix, that is the separation between class means. In this criteria, the eigenvector associated with lambda max gives the direction of maximum discriminative power. Given SW is equal to 2001, SB is equal to 8442. Compute the largest generalized eigenvalue lambda max for the matrix pair SB, SW. So here the within class scatter matrix and between class scatter matrix are given to us in the problem statement, and the used criteria is Fisher's discriminant function. So the objective function, the Fisher's discriminant function, on solving the Fisher's discriminant function, the resultant function in terms of SW and SB would be given like this. In solving Fisher's discriminant function, Fisher function, we will get the W star, that is optimized W, which separates one class with another class. So on solving Fisher's discriminant function, we will get the expression as SW inverse multiplied with SB W star is equal to lambda W star. So this lambda is the eigenvalue, again the eigenvalue associated with this SB and SW pair. So we need to get that maximum eigenvalue. That maximum eigenvalue gives the orientation of the direction in which we have a maximum separation between one class with another class. The maximum separation would be given as the minimum within class separation and maximum in between class separation. So that is what Fisher's discriminant function is giving to you, right? Now, on just rearranging this expression further, we will get SB W star is equal to SW lambda W star, from which SB minus SW lambda W star is equal to 0. So let us solve this expression for 0. Therefore, W star is not equal to 0. We need a W star which is a line, such that in this expression SB minus SW lambda is equal to 0, right? So let us obtain that SB and SW values are there with you. SB is 8442. SB is 8442 minus SW 2001 2001. So that is to be multiplied with lambda, 2 lambda, 0, 0 and lambda, right? So that is equal to 0. So 8 minus 2 lambda, 8 minus 2 lambda and 4 minus 0 is 4, 4 minus 0 is 4 and 2 minus lambda. So this is equals to 0. In order to get the corresponding lambda value that is associated with this matrix, it is obvious to get its characteristic equation because lambda is the eigenvalue. So 8 minus, so the characteristic equation is given by the determinant of this matrix. So the characteristic equation is given by 8 minus 2 lambda multiplied with 2 minus lambda minus 16 is equal to 0. 16 minus 4 lambda minus 8 lambda minus of minus plus 2 lambda square minus 16 is equal to 0. So let us knock off this 16 both sides and then 2 lambda square minus 12 lambda is equal to 0. So 2 lambda multiplied with lambda minus 6 is equal to 0 and the possible lambda values here, because this is a second order equation, characteristic equation is second order, you will get 2 eigenvalues and from the above expression we can write that lambda is equal to 0 and lambda is equal to 6. The maximum separation will be obtained in the direction of the maximum lambda such that lambda maximum, the maximum discrimination power is at lambda maximum, that is given by 6 for this given SB comma SW, such that the lambda max is equal to, so this gives your lambda max value. This is your lambda max value and we need that value here. So correct answer is 6. Next question. A 2-input neuron uses a Rollup activation for the input and the parameters below. X is equal to 2, 1, W is equal to 3 minus 1 and B equal to 1. It computes Z is equal to W transpose X plus B and A is equal to max of 0 comma Z. The desired output for this input is T equal to 5. The error is measured using squared loss. L is equal to A minus T whole square. Which one option correctly gives both the neuron output A and the gradient dou L by dou W? So the given options are option A is A equal to 6 and dou L by dou W is equal to 4, 2. Option B, A is equal to 6 and dou L by dou W is equal to minus 4 minus 2. And option C, A is equal to 0 and dou L by dou W is equal to 0, 0. And option D, A is equal to 5 and dou L by dou W is equal to 0, 0. It's a simple question where in the problem statement, a data example with its corresponding target value is given to us and its corresponding Z is given as the weight vector W, the W transpose X plus B, and that Z, if that is a positive value, that is assigned to A, and if that is a negative value, it will become 0. Okay, right. So that gives A, and the square loss is given by that A minus the target value whole square. We need to get this dou L by dou A value. We need to get dou L by dou W value. Here, first of all, we need to calculate W transpose X plus B value. So that is equals to W is 3 minus 1. So it is 3 minus 1 in its transposed form. The X value is 2, 1. X value is 2, 1 plus B. The given B is 1. B value is 1, such that it is equals to 6 minus 1 plus 1. So that value is equal to 6. Your W transpose X plus B value is equal to 6. Now A is equal to maximum among, this is your Z, maximum among 0, 6. So A value is equal to 6, and A is nothing but your Z. A is nothing but your Z. So A is your W transpose X plus B. Your loss L is given as A minus T whole square. So that is equal to W transpose X plus B minus T is 5 whole square. Now, according to this, we need dou L by dou W. So that is equal to 2 times W transpose X plus B minus 5 multiplied with, for W transpose X plus B, for this W transpose X, because it is with respect to W, it gives multiplied with X. So W transpose X plus B is nothing but your Z value, that is or your A value. So that is 6. We already have that. So 2 times 6 minus 5 multiplied with X. X is not a value. X is a vector. It is the vector 2, 1. It is the vector 2, 1. Such that it is equal to 6 minus 5 is 1, 2 times 2 is 4, and 2 times 1 is 2. So this would be your the gradient dou L by dou W. So go through the options. A equal to 6 and dou L by dou W is equal to 4, 2 is there in option A. So option A is the correct answer. The given question is, a city installs 2 emergency response hubs along a straight road. Hub A at A is equal to -3 and hub B at B is equal to 9. For an incident at location X belongs to R, the dispatch system computes G of X is equal to modulus of X minus A minus 1.8 modulus of X minus B. It dispatches hub A if G of X is less than 0, otherwise it dispatches hub B. Round any boundary point to 2 decimal places. Which of the following statements are correct? There are exactly 2 real numbers of x such that g of x is equal to 0. That is option A. Option B, the point x is equal to 25 is dispatched to hub B. Option C, every x that is in between 5 to 23 is dispatched to hub B. That is option C. And option D, the dispatch rule can be implemented using a single threshold value t such that hub A is chosen for x less than t and hub B has been chosen for x greater than or equal to t. So what is given to you in the problem statement? Here in the problem statement, it is given that there is a straight road on which you have two hubs. One hub is at a location A, that is -3, and another hub is at a location B is equal to 9. So there is a road, or this will be considered as your x direction. On this, we are having a point A is equal to -3 and another point B is equal to 9. So A and B are the break points, and there is a g of x which decides A is equal to -a equal to, at this place you have hub A, and this is the place where you have hub B. And if g of x is less than 0 and g of x is greater than 0, are deciding which hub has to respond first, or the emergency team from which hub needs to be sent. That will be decided by g of x values. If g of x is less than 0, hub A. If it is less than 0, then hub A. And if it is greater than 0, then hub B needs to be responded. And what is this g of x? Your g of x is given as the Manhattan distance of the incident happened point, that is x, to A, and the Manhattan distance of the incident happened point to B. And of course, this is scaled by a factor 1.8. That means this has to be considered as some optimized model. Okay, so this is some distance based optimized model, and so that is giving absolute value of x minus a minus 1.8 times absolute value of x minus b. This is your g of x. So this is equals to absolute value of x minus a, means minus of minus 3, x plus 3 minus 1.8 times x minus b. X minus that b value is 9, right? This is your g of x. So now we need to decide for what values of x this g of x is less than 0, and for what values of x your g of x is greater than 0. In order to know that, or in order to decide that, here we are having three possibilities. One is x is less than a, that is case 1. This is case 1. X is in between a to b. X is in between a to b. That is your second case. And x is greater than b. That is your third case. These are the only 3 possibilities. So, associated with the first case, x is less than a means your x less than a gives x is less than minus 3, as well as that x is less than 9 also. Similarly, associated with second case, x is greater than minus 3 and x is less than 9. And for the third case, x is greater than minus 3 and x is greater than 9. Right? Now, every case gives you, now here, associated with every case, there will be a threshold. That threshold may exist or it may not. That we need to decide. So, for case 1, that g of x is given as, because x is less than minus 3, your modulus value of x plus 3 would be a negative value, such that I am always taking that as minus of x plus 3 minus 1.8, and because x is also less than 9, modulus of x minus 9 would also be a negative value, such that it would be minus of minus plus x minus 9. Right? So, your g of x is equal to 1.8x minus x, that is 0.8x plus plus into minus 1.8 multiplied with 9 minus 3. This value is negative of 19.2. This would be your g of x associated with first case. Always the boundary or the threshold value associated with this case would be given by making g of x is equal to 0. If I would make this g of x is equal to 0, then obtained x value should be less than minus 3. That should be less than a. So, let us calculate that x. X is equal to 19.2 divided by 0.8. That value is becoming 24. X is equal to 24 does not lie between below minus 3. You know that? It does not lie below minus 3, such that there is no threshold value associated with this case 1. So, no threshold is with case 1. That is one observation. And another observation is, whenever if you consider any value of x, now from this expression g of x is equal to 0.8x minus 19.2, let us consider the expression that is associated with this case. Consider your g of x associated with this case, that is 0.8x minus 19.2. And see here, x is always a negative value, that is less than minus 3, means it is always a negative value. So, your g of x would always be negative. So, this g of x is always negative. What do you mean by that? Associated with case 1, the corresponding g of x is less than 0 and case 1 is always assigned to case 1 is always assigned to hub A. Any value that is associated with case 1 is assigned to hub A. Now come to case 2. Let us analyze our second case. Second case is associated with x is greater than 3, such that in your g of x, we have the modulus value would be a positive value, such that x plus 3 would always be a positive value, minus case 2 is associated with minus 3. Your x is in between minus 3 to 9, such that x plus 3 minus 1.8 multiplied with again x minus 9 would be a negative value because x is less than 9, such that again it would become plus x minus 9. So this is equal to, so this is 2.8x minus 13.2. This is your g of x. Now, in order to obtain the threshold that is associated with this case, and the threshold may exist or may not exist, just like your previous case, your g of x is equal to 0. That implies the corresponding x would be 13.2 divided by 2.8, and that is approximated to 4.71. 13.2 divided by 2.8. Now you just check, x is equal to 4.71 is a value in between minus 3 to 9, and for this x is equal to 4.71, g of x is equal to 0. Okay, so g of x is equal to 0 for this specific x that is lying in between minus 3 to 9, right? Such that anything that is in between minus 3 to 4.71 gives g of x less than 0, and anything that is above 4.71 and 9 gives g of x greater than 0 in this specific case. So, because g of x is equal to 0 is defined at this x is equal to 4.71, the obvious point here is anything that is in between, any value of x that is in between minus 3 to 4.71 gives g of x less than 0. That means it is assigned to hub A, and anything that is in between 4.71 to 9 is assigned to g of x, it gives g of x greater than 0. That means it is assigned to hub B. Next, in a similar manner, you need to analyze case 3 also. You take up your third case where your x is always greater than 9, which means its corresponding g of x is equal to x plus 3 is positive for x greater than 9 minus 1.8 x minus 9. Okay, now if I would calculate its corresponding g of x is equal to 0, then it results, or it gives an x value is equal to 24. It gives me a x that is equal to 24. Now, according to this idea, if x equal to 24 is giving me g of x is equal to 0, and here x greater than 9 is the possible values of x, and in the range of 9 to 24, g of x would be negative values, right? So in the range if your x is in the range 9 to 24, then your g of x would be, right, this is x greater than 9, such that g of x in between 9 to 24, g of x would be greater than 0. And similarly, x greater than 24, x greater than 24 gives your g of x less than 0. So that means this is assigned to hub B and this is assigned to hub A. So now analyze or consider all the three cases and just that means now how many thresholds we have. The thresholds are always belongs to g of x is equal to 0. You are having two thresholds. One is at 4 point something, that is 4.71, and another threshold is at 24. Right. Now carefully combine case 1 where g of x is all the points that are less than -3 will be assigned to hub A. Not only that, in between -3 to 4.171 is also assigned to hub A, such that -infinity to 4.71 hub A. So the final assignment. So the final assignment would be like this. And combining case 1 with case 2, we are getting any value of x in between -infinity to 4.71 is assigned to hub A. And now combine case 2 with case 3. Anything that is in between 4.71 to 9 is assigned to hub B, and 9 to 24 is also assigned to hub B. So anything that is in between 4.71 to 24 is assigned to hub B. So from case 2 and case 3, anything that is in between 4.71 to 24, any value of x in between this range is assigned to hub B. And the final statement, anything above 24 is again assigned to hub A. So 24 to infinity is again assigned to hub, right? So now you go through the options one by one. With this knowledge and with this calculations, we can easily answer the given options. There are exactly two real numbers of x such that g of x equal to 0. 4.71 and 24 such that it is a true statement. Option A is correct. The point x is equal to 25 is dispatched to hub B. Anything above 24 is assigned to hub A. So option B is incorrect statement. Every x in between 5 to 23 is dispatched to hub B. Hub B is in between 4.71 to 24. So 5 to 23, x belongs to 5 to 23 is belonging to hub B is a correct statement. And finally, the dispatch rule can be implemented using a single threshold of t such that hub A is chosen for x less than t and hub B is chosen for x greater than or equal to t is an incorrect statement. There are two thresholds t1 and t2. X less than t1 hub A, x in between t1 to t2 is hub B, and x greater than t2 is again hub A, such that it is not implemented using a single threshold and it is implemented using two threshold values, such that option D is an incorrect statement. So the correct answer is A and C. The given question is, the method starts with each point as its own cluster and repeatedly merges clusters based on a chosen linkage criteria. For example, single linkage, complete linkage, average linkage, etc. The result is a dendrogram, and a final clustering can be obtained by cutting the dendrogram at a chosen level. Which of the following statements are correct? Option A, agglomerative hierarchical clustering does not require the number of clusters k to be specified in advance. And option B, once two clusters are merged in agglomerative hierarchical clustering, that merge decision cannot be undone later in the algorithm. And option C, in single linkage, the distance between two clusters is computed as the average distance over all pairs of points across the two clusters. And option D, the final clustering obtained from hierarchical clustering can change if we switch the linkage method from complete linkage to average linkage, even when the same distance metric is used. Right, let us go through option by option. Actually, the hierarchical clustering, that is agglomerative hierarchical clustering is given, and we know in agglomerative hierarchical clustering the linkage methods are used, and based on the linkage methods the merging takes place at the minimum distances of the clusters. The clusters with minimum distances will be merged together. Now, it is given that in option A, agglomerative hierarchical clustering does not require the number of clusters k to be specified in advance. Not only agglomerative, even in divisive also, the k value is not required. Only in k-means and k-medoid algorithms. In those algorithms, the k value is to be specified a priori. And in agglomerative as well as in divisive approaches, k value need not be specified, and after constructing the dendrogram we can do a cut at the desired level, and based on that we will consider the clusters. This is the fundamental difference between the two methods. Okay, right. So in agglomerative hierarchical clustering, it does not require the number of clusters a priori, so that is a true statement. Option A is correct statement. And another important characteristic of agglomerative approach is, once the merging is done, it is not possible to separate at the another level. So, once two clusters are merged in agglomerative hierarchical clustering, that merging decision is final and it cannot be undone at the later stage. So, option B is also a correct statement. These two are two important characteristics of the agglomerative algorithm, agglomerative hierarchical algorithm. And then option C, in single linkage, the distance between two clusters is computed as the average distance. It is incorrect. It is computed as the minimum distance over all pairs of points across the two clusters. In single linkage, it is minimum, and in complete linkage, that would be the maximum, but not average. In average linkage, that would be the average of all the pairwise distances between the clusters. Right, such that option C is an incorrect statement. And then option D, the final clustering obtained from hierarchical clustering can change if we switch the linkage method. So if the minimum distance, maximum distance and average distance between the clusters, that changes the clustering pattern. So hierarchical clustering, that is agglomerative or divisive, is a local optimization method but not global optimization method. That is one of the important conclusions from this statement. So the final clustering obtained from hierarchical clustering can change if we switch the linkage method. Even with the same distance metric, use Euclidean distance everywhere, but change the linkage method from single linkage to complete linkage. Then the clustering pattern would change. Your dendrogram structure would change such that the final clustering will be changed completely. So option D is a correct statement. So your answers, correct answers would be A, B and